Good morning.
Good morning, sir.
Yes, good morning. I'm Professor Vagya.
Morning, sir.
Yes, good morning.
Good morning, ma'am.
Morning, ma'am.
Good morning.
కనిపించండి సార్ కనిపించండి ఇద్దరు ఉంటాం ఓకే ఓకే Hola, good morning everyone. My name is Anjani, IKC coordinator of this 1956 established SRN BGNA Government Arts and Science Autonomous College, Khammam. A good morning to all the dignitaries with an immense exultation and amiable welcome to all. Today, Department of Chemistry of our college is organizing a one-day international webinar on recent trends in phytochemical research and drug discovery. Welcome, bienvenido. Now, let us have the pleasure of listening to the opening remarks of the webinar convener, Dr. P. Ramesh, an excellent researcher and head of the Department of Chemistry, and who received the Best Teacher Award of Telangana State in 2019. I welcome, sir. Welcome, Ramesh.
Thank you very much, Ms. Anjani Madam. Good morning, all. It's my privilege to welcome you all and thank you for your interest and spending time for our international webinar on recent trends in phytochemical research and drug discovery by our chemistry department, Department of Chemistry, SRN Vijayanagara Government College, Khammam. In our Telangana state, government colleges are facing a competition from the private colleges. Still, the admissions in the government colleges are ever increasing year by year. This total credit goes to our dynamic administrator and honorable commissioner of Sri Navin Mittal IAS Garu. In his able administration, a lot of changes are taking place in our government colleges system, like introduction to English medium for all the students, encouraging the students to participate in Jignasa research programs, and organizing Yuvatarangam programs. So many programs are organized by our CC team, and they are very much encouraging our students and inculcating high level of knowledge and enthusiasm in our rural students. And students are now able to do some research even at graduation level by hands-on experiments, by doing Jignasa programs, and they are able to present their research programs on the state level platforms. Now, many students are getting admission into Central Universities of India and even campus seats in Osmania, Kakatiya universities. All this credit goes to our dynamic commissioner, sir. In continuation of this, our Department of Chemistry is planned to organize an international webinar to get the exposure and knowledge to our students by this type of programs. So that they can receive knowledge from internationally acclaimed personalities. I am very grateful to our principal, sir, in encouraging us to this type of program, and we are very thankful to our commissioner, sir, Sri Navin Mittal IAS Garu, our JD sir, Dr. Yadagiri sir, RJD sir, Dr. Rajendra Singh sir, and AGO sir, Dr. P. Balabhaskar Garu, and all other CCE team, especially Dr. Nirja Madam, who encouraged us to conduct this type of program. So I request you all, the participants, to stay logged in till the end of this program to get the exposure and knowledge from the internationally acclaimed personalities. So thank you very much once again. Thank you.
Thank you, sir. Thank you for your welcome address. Now, I am very glad to invite our respected principal, sir, K.S. Ratna Prasad, to give his remarkable opening remarks on this occasion. Welcome, sir.
Good morning, everyone. On behalf of students and staff, I cordially welcome Right Honorable Commissioner of College Education, Joint Directors, Dr. Adhikar sir, Dr. Rajendra Singh sir, AJO sir, Dr. Balbhaskar sir, Nirza ma'am, and all the participants and resource persons of the day. Once again, good morning. I thank a billion for joining us. In first place, we deem it a privilege to have our dynamic, charismatic Commissioner of College Education, Naveen Mittal sir, on board today. Under his magnetic spell and charismatic leadership, a golden era ushered in government degree colleges sector. Sir has changed the very face of government degree colleges with his vision and great leadership. I call Sir a harbinger, a forerunner, because Sir has, under his dynamic leadership in colleges, everything has been changed. English medium has been introduced in rural setup colleges also, and all on top of it all, Sir is a visionary because during this pandemic and the onset of pandemic in our country, way back in April, in one of the webinars Sir attended, Sir remarked that we should not waste the academic year of the students. So we have to seek other avenues to teach the students. So Sir, on that day, on that webinar, Sir highlighted that online platform is the alternative source of imparting education to the students. Couple of days after, Sir enthused every teacher working in government degree colleges, especially to go on online teaching. So I call Sir a foreigner in all fronts. We thank you very much, sir, for your dynamic leadership and whatever thoughts that come into Sir's mind. Our dynamic team of the joint directors and Balbhaskar sir, AJO sir, and other academic officers translate Sir's thoughts into action, and thereby we are in a good position to claim that we are the best in the business as far as imparting education is concerned. With these few remarks,
Okay, thank you, sir. Thank you for your supporting and kind words. So now, I'm very happy to take the opportunity to invite today's guest, Dr. Balabhaskar Garu, to give his speech. And I request V. Shantikumar sir, Assistant Professor of Chemistry, to introduce our guest.
Sir, experienced 25 years of teaching experience as lecturer and 6 years of experience as principal, and has got MSc and PhD degree in physics from Osmania University. Sir got gold medal award by Osmania University in 1988 in MSc Physics as overall topper of the university. Pratibha Puraskar Award as Best Principal from Siddipet district. He has many parts. He has participated in the many workshops and seminars and conferences of physics, national and presented papers, also acted as resource person. Sir undertook research activity as invited research scholar for 1 year relating to lifetime measurement of luminescent centers in crystalline solid at Baba Atomic Research Center, Trombe, Mumbai, as part of PhD program in 1998-99. Having research publications in national and international journals, he was appointed as APPSC as lecturer in Physics, Government Degree College, Ladwell, and worked as member of subject expert in several committees, academic advisor of to many junior and degree colleges in the state, member of IPSC committee for NAC at Government Degree College, Ladwell. And his services are extended for prepared the scripts and presented live lectures in Mana TV through SAPNet for undergraduate students. Author the following textbooks for BSc students and publications by Telugu Academy Government of Andhra Pradesh. BSc textbook Mechanics, Waves and Oscillations for first year in 2004. BSc textbook Mechanics, Waves and Oscillations on revised syllabus for first year 2008. Author entrance question bank, 2 volumes published from Telugu Academy. Sir was member of Alumni Association in Physics, Osmania University, member of Osmania Graduate Association Exhibition Grounds, Hyderabad, member Society for Promotion of Adult Continuing Education, Space, Hyderabad, member of the Forum for Higher Education, AP Hyderabad, member Forum for Promotion of Moral Values, registered Secunderabad. With this brief introduction, now I would like to invite Sri Dr. P. Balabhaskar Garu. Please address the today international webinar, sir. I'm handed over to the Anjali Madam. Thank you, sir.
So I welcome Balabhaskar sir to give his message. Welcome, sir.
Good morning to all the participants who are there on the group. I'm very happy to be with you once again for a webinar. It is a wonderful event that the Khammam Degree College is organizing. in this COVID situation time. I think this is fourth or fifth international webinar that you are conducting. It is a very, very happiest thing that we can say. Series of webinars are being organized by SRN and BGNR Common Degree College. So for this, first of all, I must congratulate the leader of the college, that is principal, and his team, especially the Anjani Garu and other supporting staff who are there with the principal to organize such wonderful programs. So you are organizing the programs even in a diversified topics. Last time you organized on a environmental issue, and this time you are going for drug chemistry. Like that, you are choosing a very diversified and very important issues that are need for the hour to give or to enlighten the students as well the staff of all the participants who are there on this particular platform. So very happy to be with you once again. So on this occasion, I also give my message or what I can say to all the staff members of the Common Degree College that organizing such seminars will definitely improve the quality of the higher education. This is one way how to go into the public, how to bring our college name into the limelight. I think this is the best way to organize a series of webinars or seminars, physically or virtually. So definitely this will bring many of the people from all over the world to be with us for one day, and they will share their knowledge, and with that our staff members as well our students are going to enlighten a lot with those things. So organizing a webinar is not a simple thing. A lot of background work to be done for this, but I am very happy the Common Degree College has got a very good team to do all these webinars in a short span of time. I hope this will continue in the college. Definitely college going to get a good reputation nationally and internationally by these particular activities. And of course, these activities will also very useful in the accreditation assessment processes also. As you all know, more than that, we are enlightening the students as well the staff members on the current issues like drug chemistry, like environmental issues, and many other issues what you are taking. So very happy to be with you once again. And first of all, I must also thank the organizers, especially the principal of the college, for inviting me repeatedly for all your webinars. For that, I am very, very happy and thankful to you all. I also thank the resource persons of today. On behalf of Commissionerate, I thank them because they are spending their valuable time of one day with us and sharing their knowledge and opinions, sharing their whatever the valuable ideas with our students and the staff is a very good thing. First of all, I must thank them on behalf of our commissionerate to all the resource persons who are involving in such webinars from nationally or internationally. So I once again appeal to the organizers as well to the principal, please keep going like this with all these seminars and webinars continuously so that you can improve the credibility of the college in the society or in the Telangana state. So I once again congratulating all the organizers on this occasion and also thanking for giving me a good opportunity on this. Please keep going in all these activities in future also. Uh, improve the quality in higher education by these activities in coming days. I thank once again Principal Garu and also the organizers of the webinar for inviting me and giving me this opportunity for being with you for this moment. Thank you, one and all.
Thank you, sir. Thank you, sir, for your words and encouraging message. Thank you once again, sir. Thank you.
Okay. Now, with so much enthusiasm, I would like to invite Dr. RJD CCA, and I request our Assistant Professor of Chemistry, M. Balakrishna, to introduce our guest.
Thank you, ma'am. Good morning, ladies and gentlemen. It's a great pleasure for me to introduce our distinguished guest, Dr. Adagiri sir, JD FAC, CC Hyderabad, who is going to address the today's international webinar on recent trends in chemical research and drug discovery 2020. Our distinguished guest, although having spent almost his entire career advising the people, teaching the students, and making them employable in different places. His areas of emphasis are organizational, culture and change, administrative simplicity, and leadership development. He has done his master's from the Usman University, Hyderabad. Over 20 years of experience in teaching, joined as a lecturer in geology at Nagarjuna Government Degree College, Nalgonda through APPSC, and served from November 1991 to September 23rd, 2012, and then promoted as principal in 2012 and placed at MVS Government Degree College, Mahabubnagar. He has transferred to Government Degree College for Women, Begumpet in 2018. Presently, he is serving as JD FAC, CCE Hyderabad. He participated at many national and international seminars and conferences. He is also serving as a member in Alumni Association, Department of Geology, Usmania University. Further, he was an executive council member at Mahatma Gandhi University, Nalgonda. From 2013 to 2019, he got the Best Teacher Award in 2007 and also Best Principal Award in 2016 by the government. Under his supervision, 2 major research projects are under progress. 1 major research project has been done successfully. He has many publications at national and international level. With this brief introduction, now I would like to invite Dr. Adagiri sir. Please address the today's international webinar. Thank you, sir.
Welcome Dr. Yadagiri sir to give his message. Sorry for the inconvenience. Sir will join late due to some. So now, it's my pleasure to invite Dr. S.R. Rajendra Singh, RJD, CCE, and I request our Assistant Professor of Chemistry, Y. Mahesh, to introduce our guest.
So thank you for being here this morning. It gives me an immense pleasure to introduce and welcome today's guest, and Dr. D.S.R. Rajendra Singh, Regional Joint Director, FSC Zone 5, and Principal GDC Kairatbad, Hyderabad.
Hello.
Sir has 30 years of experience, undergraduate.
Hello.
As
Good
an
morning.
assistant professor as well as principal. 10 years at postgraduate level. In his career, Sir faced 3 times NAC, till now successfully got good accreditation to his college. As an administration, Sir has 20 years of experience and 10 years of research experience. He has authored 70 books and 25 research papers and 20 articles, and Sir organized 8 seminars, which includes national and international levels. Sir gave 14 radio talks and 2 Mana TV programs. Sir attended 9 international conferences and 22 international conferences and 40 seminars. Sir has 20 years of social service experience in NSS, NCC organizations also. So, Sir has honored with several awards, and one of the best principal award in 2017 during Yodarangam by CCE, and State Best College Teacher Award in 2003. All India NCC Director General Commended Award in 2008 by Organizer of Defense Corps in India. So, thank you so much for accepting our invitation. May I know or request you, sir, please address the gathering. Thank you.
I welcome Rajendra Singh sir to give his message. Welcome, sir. Welcome. So please unmute yourself, sir.
Hello, good morning. Yeah, is it audible? Yeah, good morning, everybody.
Good morning, sir.
Good morning, sir. Okay. Good morning, everybody. On behalf of Commissionerate, our beloved Commissioner and the Joint Director, Dr. Yadagiri Garu, Sri AGO Balabhaskar Garu, the Principal of the College, Khammam Degree College, then the other conveners and the Chief Guest and the main resource persons, those who are taking part in the webinar. Really, it is one of the very important topic which you have chosen. As the AGO sir, he said the several webinars you have conducted with different diversified topics. Really, once again, I am congratulating. Really, today topic is also going to be very important topic. Like a young researchers, young staff, the important staff, and as well as the very important the participants, those they are going to be participating because of the due to this COVID situation. We are also going to be involving a conducting beautiful seminars with the inspiration of our beloved commissioner. So the topic is phytochemistry is one of the very important topic which you have chosen. This is one of the very important topic nowadays. The phytochemistry is nothing but it is the chemistry which is going to be generated, the natural products which are going to be coming from the plants. So nowadays it has been totally gained, it has been totally gaining the importance among the world, because everybody is going to be thinking towards to the Ayurveda, what the plants are, what the nature is going to be giving, and what type of products are going to be coming. Nowadays, there are so many products, especially the Indian biodiversity. If you see everything, every plant is having its own importance. Every plant is going to be producing important chemicals. The chemicals, hydrocarbons, and now whatnot, all the different types of the drugs which are going to be produced by these things. So these are all going to be useful for the nature. And really, you have chosen a beautiful topic. And the nowadays the phytochemistry, even the Aish people are also going to be they are going to be reminding us towards to the important drugs of the coronavirus. Not only that, the drugs which are going to be having the important microbes which are going to be killing, and as well as the important hydrocarbons now we are going to be generating. Now we are going to be generating important hydrocarbons from the even petro plants are there. These petro plants are going to be producing the petrol products like all the things. In future, if you are going to be giving more concentration on this phytochemistry, because India is a diversified country, India is a biodiversity, richly biodiversified country, we have to protect our biodiversity. We have to protect each and every species. Especially you have to recognize the species, those who are going for the endangered, all such species, so that especially I am congratulating the Khammam Government Degree College, the principal and as well as the conveners of the webinar, and the staff taking the good initiation, good motivation, and as well as conducting such type of the webinars. And really, I am once again I am congratulating. Really, one of the very important, the beautiful topic which you have chosen. It's the current topic which you have chosen. That is one of the very important aspect. That is a one very important applied topic. Really, with this, I don't want to take much amount of your time. I am once again congratulating all the participants, especially the resource persons, though they came from the global resource persons you have invited. Really, it is one of the very important aspect. Really, it is going to be depending upon our PR, which we are going to be maintaining the relations, so that finally, I don't want to take much amount of the time. Once again, on behalf of Commissionerate, on my own behalf, I am once again congratulating for the conducting such a beautiful webinar, and especially the principal and the staff members, the organizers, and as well as for all of them. Really, once again, I am very much thankful for inviting me for attending this such a program. Okay, so with this, I conclude my message. Thank you. Hello? Hello?
Thank you, sir. Thank you very much for joining us today.
Thank you, sir. Thank you very much for joining us today.
Thank you. To introduce our honorable and technical education and chief patron of today's webinar, Sri Naveen Mittal IAS Garu. It's my privilege to share some activities, in fact, adventures of him. A Delhi IITian turned into an IAS who stood third in All India Civil Service Examinations in 1995. As collector and district magistrate of Krishna districts, Sir restored colleague from the hands of mafia. and he was successful against the immoral activities of microfinance organization in Andhra Pradesh. Mr. Naveen Mistal sir took an initiative called Pallenidra, which is an innovative program of making a night halt in villages to solve the issues. Sir led the rescue, relief and rehabilitation efforts against the large-scale flooding of Krishna district. The Commissioner for Visakhapatnam Municipal Corporation, he brought CRISIL Award in 2003 for the corporation. And as in charge of ITDA, his works were recognized by World Bank. As Collector and District Magistrate of Hyderabad District, Naveen Garu actively worked on upgradation of government schools. And he received so many awards, the Rotary Club Award and Environmental Clearance Bank Award. The list is so big. If we go on continue, it takes much time. So welcome, sir. If sir is here, I welcome you to give his. Okay, sir will join us later. So let's start our session. So now we are entering the first session of today based on recent trends in phytochemical research and drug discovery. I'm very much elated to take an opportunity to invite Dr. K. Suresh Babu, Principal Scientist, Division of Natural Products Chemistry, CSIR, Indian Institute of Chemical Technology, Hyderabad, on the topic importance of natural products and their contribution to health and society. Now I request Dr. P. Ramesh, HOD, Department of Chemistry, to reveal the detailed profile of the resource person. Welcome, sir.
Good morning, all. I am very much excited to invite Dr. Katragadi Suresh Babu Garu, who has been serving as a Principal Scientist, Center for Natural Products and Traditional Knowledge, CSIR, Indian Institute of Chemical Technology, Hyderabad, India. His rich research profile will definitely inspire us to reach new heights in our dream fields. Dr. K. Suresh Babu obtained his master's in 1999 and PhD degree in natural product chemistry in 2005 from IICT Hyderabad and the PhD degree awarded by the Kakatiya University, Warangal. Later, he joined as a postdoctoral fellow at University of Mississippi, USA for 3 years. He joined as a scientist in CSIR, Indian Institute of Chemical Technology, IICT, Hyderabad in 2007. And at present, he is in the position of Principal Scientist in the Division of Natural Products Chemistry and Traditional Knowledge. In his research career, Dr. Suresh Babu has successfully isolated several new bioactive molecules from natural resources. He has authored 160 research articles in SCI journals and filed 10 patents in India and US. Under his able guidance, 18 scholars completed their PhD and 9 scholars are pursuing at present. He has honored with several awards such as OPPI Young Scientist Award, Organization of Pharmaceutical Producers of India, Mumbai, for the year 2010. He is Andhra Pradesh Academy of Sciences Young Scientist Award for the year 2010. Best Performance Award for the year 2011 conferred by Director IICT Hyderabad. He is a fellow of Association of Biotechnology and Pharmacy ABAP in the year 2016 and fellow of Andhra Pradesh Academy of Sciences in the year 2018. He is a reviewer, member of editorial board for several national and international journals. He is leading many projects of national importance in new drug discovery, standardization of herbal drugs of commercial importance. His research interests are new drug discovery from natural products, herbal drugs, and their standardization, botanical pesticides, chemical modification of lead compounds, and structure activity relation studies, SAR studies. Thank you very much, Dr. Suresh Babu sir, for accepting our invitation and also guiding us to conduct this type of international level programs. May I now request you to share your rich expertise and address the gathering. Thank you.
Yeah. Thank you, Ramesh, for your nice words. And once again, thanks to the organizing committee for having me in this international webinar. And I am very much happy to be part of this international webinar. And I will try to maybe in the next 1 hour or so, I will try to emphasize about the importance of the natural products and how they have contributed in the form of drugs for the human well-being. And also, I will also give some of the examples of the drugs, famous drugs, which are in the present market, evolved from different natural sources like medicinal plants, marine flora, and lichens and other sources. And finally, I would like to emphasize about the drug discovery process, which is involved in from the natural product different stages. What are the stages involved and what are the important stages? And finally, I will give you a glimpse of our activities regarding the natural products drug discovery from IICT. And now I am trying to share. No. Okay. Share. Now, Ramesh. Hello. Hello.
Screen is shared, sir.
Yeah. Am I audible?
Yes, sir. Suresh Babu, sir.
Yeah. Am I audible? Yeah. Good morning once again to all the organizing committee members. Just I would like to share and emphasize about the importance of the natural products. It is well known that the plants are the real companions of the human beings, but not vice versa. So in the olden days, actually in the ancient times, we can call it ancient times, the humans, they have identified, even though they do not have any knowledge and education, but they have identified based on their local knowledge the plants surrounded by them as a medicinal plants and as a poisonous plants. So based on their knowledge, that knowledge has been rooted to their generations together to generations and transmitted to the generations and formed like a traditional systems of medicine, which is now it is called like Ayurveda, Unani. All these systems has been evolved like that only. Not only Indian traditional system, the other systems also, African traditional system, Chinese traditional system, all the systems has evolved like that. So but now because of this imbalance in the environment or atmosphere, there is a huge changes were in the atmosphere. As we have seen in the last month, there is huge rains which we have never expected in the last I think 100 or 125 years. That's what the government has announced. Even Hyderabad, one day there is a huge rain, almost 120 or 100 centimeters heavy rains, and this time Hyderabad has a huge floods. This all because of this changes, huge changes in the environment, and there is a huge imbalance in the atmosphere that which causes all the high temperatures, heavy rains, and all those things. And also there are other things which are affected in the environment is exploiting population, massive pan-tropical deforestation, removing the forest, and increasing the fossil fuel use, which ultimately leading to a global warming. And these all leads to the incidence of new deadly diseases and untreatable global diseases. For example, SARS, avian flu, swine flu, HIV infections, now the pandemic, COVID-19. And also the long-term usage of the drugs leads to the development of the resistance in our body, and sometimes so that is also one of the biggest problem. And these are the major killer
Master sir.
diseases in the world: AIDS, tuberculosis, diarrheal diseases, malaria, hepatitis
అన్నా
B
ఈ
virus,
పని
SARS, avian flu, and tobacco related diseases. Here you can see the figures. Every year, almost more than 1 million deaths are happening for all these diseases, and more than 2 million new cases are finding. So even though drugs are available, but there are no globally available treatments. Most of these diseases in the last stage or in the fourth stage. So now you can see the pandemic is COVID-19. So even though we are spending, we are ready to spend as much as money, but no drug is available. Particularly this COVID-19. Of course, vaccine is coming maybe in the coming 4 or 5 months or so. And modern lifestyle is also one of the important factor for our bad health. Here we can see the home theaters has a multiplex in the living room, and here see the whole family is busy with their cell phones. So, and restaurant culture, this is a modern lifestyle which really needs to now. If you um, if you see majority of the metropolitan cities, the people are having the almost 60 to 70% people are having deficiency in the vitamin D and vitamin B, as well as many people are suffering from sugar, diabetes. As you know, India is a diabetic capital of the world. So the modern lifestyle is also some amount it is contributing to the unhealthy habits and all those things. So by seeing all this, then definitely there is a healthcare crisis in the globally, and for getting a drug into the market cost almost 1 billion US dollars, and even the drugs are too expensive. Even though it is expensive, but no drugs are available for critical global diseases. So, and you cannot use synthetic drugs for a long time, because that is also having the similar side effects, and it's not sustainable for the long time. And at this junction, can we think about our traditional medicines? Because our kitchen itself is a treasurer of traditional medicine, or our traditional medicine, and many of the spices which are well known, and they are having their own importance for all the properties. So, but the only issue is with is a very poor quality control and a lot of adulteration. But at this revolutionary scientific in the present scenario, we can come across all the quality control aspect, and we can do much improvement in the quality control aspects also. Yeah, what is a traditional medicine? Even WHO also defined traditional medicine as the sum of the total knowledge, skills, practices based on the theories, beliefs, experiences of indigenous cultures, whether applicable or not used in the maintenance of the health. Before the 19th century, all the medicines are called as a traditional medicines. Of course, it is called in different names in different countries. The term complementary medicine, alternative medicine, and non-conventional medicine, etc., are used interchangeably with traditional medicine in some countries. If you go to Europe, it is called as a nutraceuticals. In the US, United States, is called a botanical medicines, botanicals. So, of course, the raw materials for all traditional medicines mainly the medicinal plants. So, the traditional medicine refers to medicinal knowledge, innovations, practices of the local communities around the world, and the traditional medicine developed from the experience gained over the centuries, and it has been transmitted orally from the generations to generations. You can see if you visit the rural areas or the interior areas of our state or country, the tribal people particularly, they have completely depend upon their primary health care on the folklore medicines, that is the plant extracts or plants around surrounded by the nearby them or nearby the forest. So they are still using those folklore medicines, and which has been prescribed by the some people are called traditional healers. So those traditional healers are not even having the MBBS degree, PMP, RMP, but they have been experienced by their fathers or forefathers, and they know the plants, even though they are not at all educated, but they know the plants which will work on the different diseases. So these traditional healers, they are serving the tribal people in the countrywide, like starting from this Gujarat to northeast and Jammu Kashmir and south region, Nalamala forest region, and our Telangana Adilabad region, Karimnagar region, Mulugu forest region. So there are many people are existing, and recently Government of India also conducted a survey regarding the existence of the traditional healers, and almost more than 10 lakh people are existing in the worldwide, and they are the very good, and they are contributing, and they are contributing their part for the well-being of the tribal people by prescribing, by serving the folklore medicine in the tribal areas where there are no hospitals in those tribal areas. So of course the traditional medicine in India can be classified into two categories. One is codified, that comes under Ayush Ministry, Ayurveda, Unani, Siddha, and Homeopathy, and a non-codified folklore medicine system. So that's this medicine system mainly practiced by the tribal people in the interior areas of the particularly in the forest region tribes. And of course, both the systems has contributed equally to the primary healthcare in India. Particularly, this is the pictorial where the traditional medicine is serving from the last 4,000 years. And in this present scenario, in the revolutionary changes in analytical techniques and biological techniques, we can do much better. So these are the just pictures taken from different countries where the contemporary traditional medicine over to the counters of the traditional medicine, like Iran, Colombia, South Africa, Cape Town, and China. Even South Africa, China, and India, these are all well established in their traditional systems of medicine, and very old systems of medicine. And our China and India also very old systems of medicine, but the thing is, in China still people are practicing their traditional systems of medicine, TCM, but in our country very few people are practicing. And these pictures, when you visit the tribal people or forest area people, you can find this type of people. These people are called traditional healers. So see, they are going to the forest and plucking some of the medicines, leaves and roots, collecting the roots of medicinal plants and making the medicines, and giving to the people who are suffering from different diseases. Even If you go to some of the interior areas, even till today in this modernized era, people are only dependent upon this plant-based medicines. For best example is the northeast area of northeast part of India, and the Andaman and Nicobar Islands. In the Andaman and Nicobar Islands, the native tribes are called Andamanis and Nicobaris. Those are native tribes, and of course there are now very less population are there. Government is giving more subsidies to improve their population, of course. And those tribes, they have not even taken single paracetamol and a single antibiotic in their entire life. But they are completely dependent upon their plant-based medicine their entire life, but they are doing much better when compared to our modern human beings. That is the strength of the plant-based medicines. But the only thing is, based on the importance of the natural products and natural product drugs, there is a lot of adulteration is happening in the society. Like they are mixing the steroids and all those things, but however, the pure natural products and quality control based plant based medicines works very well when compared to the allopathic medicines, and particularly these plant based medicines are very good for particularly chronic diseases. When coming to tribes, India has the largest tribal population when compared to the other countries in the world. In the figure 85 million with more than 700 groups. The tribal population of India is not a homogeneous group. This is composed of different tribes like Gutikoyas and Chenchu tribes in the Nallamala forest region, Gutikoyas in the Khammam district and Chhattisgarh area tribes, and similarly Adilabad Gondu tribes. So these are different tribes are available in the India, but not in the other countries. Our constitution recognize around 212 tribes found in different parts of the country, like Himalayan region, Northeast region, South region, Western region, and Andaman and Nicobar Islands. Still, majority of the tribes are practicing only the plant-based medicine for their healthcare system. So these are based on this. Recently, the World Health Organization has been conducted a survey regarding the utilization of the plant-based medicine by the human beings, and really it has gave a extraordinary and eye-opening results. More than 80% of the world population relies on plant-based traditional system for their primary healthcare needs, and further, it has listed around 21,000 medicinal plants which have been reported for medicinal uses around the world. These 21,000 medicinal plants are very huge usages, and part of the many traditional systems of medicine like Ayurveda, Unani, and all Siddha. When coming to our India, our country, India is very well known as a botanical garden of the world. So we have 16 agroclimatic zones and flooded with 45,000 different plant species, and has rich medicinal flora with 15,000 species. Among these, 2,000 to 3,000 plants are fairly used in the different systems of medicine like formulations and all those things. And Indian systems of medicine identified 1,500 medicinal plants, and many of them are exporting even till today to other countries. And currently, another 5,000 products are included in the pharmacy of Ayurvedic treatments. So these are the different natural sources: plant kingdom, microbial world, animal sources, marine world, and venoms and toxin. All these natural sources has contributed to the human being in the form of drugs. When compared to among these five sources, plant kingdom has contributed a lot in the form of the drugs for the human being, and in the form of a traditional medicine. And when coming to microbial world, penicillin is the best example for the microbial world, drugs derived from microbial world. Similarly, marine world, when you see the anti-cancer drugs in the present market, majority of them derived from marine world, and the animal sources and venoms and toxin, the animal sources and anti-hypertensive drugs, antifungal drugs, which has been discovered from the frogs and other animals, are in the present market for different targets. So most of on the light side, all the sources has contributed to the human well-being in the form of the drugs. So when you see different applications of the natural products are has a very good applications in the as a first herbal medicines and food and feed and pharmaceutical applications, pesticides and cosmetics. Here I have given quoted one of the very famous drugs. Here one artemisinin, very famous anti-malarial agent discovered from Artemisia innova, which is a very famous medicinal plant, and as a ivermectin B, very well-known crop protectant, and rosmarinic acid, very well-known and very well utilized as a food preservative, and trapaxin B, it's used, hugely used in biological probe. Similarly, epigenin, which is very well known as a colorant and has its wide applicability in drinks and other beverages. Similarly, linolol, very well known as a perfume, and stevioside, derived from Stevia rodendiana, very well known as a artificial sweetener. And all diabetic people will use this type of sweeteners. And linoleic acid, very well known as a lotion. And why to study the natural products? Because natural products are the source of the most complex and fascinating chemical structures, and natural products represent biological diversity, and these are expressions of the genome. Natural products represent natural biological activity, whether as a single compounds or as a complex mixtures. And natural products are the part of natural wealth of the country and can be an important source of livelihood from agriculture and food, pharmaceutical and fine chemical industry. And in the particularly in the northeast region, many of the people depended upon the natural products or plant-based medicine, plant-based as their livelihood, and also for their primary health care. And similarly, the utilization of the natural products as a drugs for the primary health care has a long history and evidence. Here I have quoted few. The therapeutic use of plants can be traced back to time immemorial. The earliest record of the use of medicinal plants dated back to 2600 BC, which is utilized by the Mesopotamian civilization. And the use of the medicinal plant in Egyptians is recorded almost in the way back to 1500 BC. In this, the therapeutic application of more than 700 drugs were documented. Similarly, most famous, the history of the Chinese medicine can be traced back to 1100 BC and obtained from Chinese Materia Medica. And these are traditionally established, particularly Ayurveda. Ayurveda, we know very well. Ayurveda is a long established system of medicine practiced in India thousands of years. And now it is getting worldwide attention as alternate systems of medicine. Even though Ayurveda and other traditional systems of medicine do not concentrate on the single molecules and are their active principles, but however, became the basis for the drug discovery of many drugs in the present market. So here I gave some of the examples of the lead compounds derived from the plant-based medicine plants which are part of this Ayurveda. Here Rahulpia alkaloids used for reduce the hypertension, derived from Rahulpia serpentina, and the soralins, which is used in vitiligo, derived from the plant Soralia corifolia. Similarly, Holari helena alkaloids used in amoebiasis. So these are all lead compounds, part of the many Ayurvedic formulations and available in the present market, which has been discovered based on the Ayurvedic knowledge. And similarly, economically affordable compared to other drugs. These are a little bit low cost and low procurement of raw material, and comparatively low toxic, provided it has to be taken in the prescribed quantity. Then only the plant-based medicines are low toxic and very effective in chronic diseases. Here I would like to quote one example regarding the toxicity of the plant-based medicines. And one of my friend is working in a working as a lecturer in one of the degree college. So he has been suffering from diabetes maybe from the last, I think 6 or 7 years or so. So he was told by one of his friend why don't you use Naxwamica bark so that you will be relieved like anything. We know pretty well Naxwamica capsules are very famous in homeopathy for diabetes. Naxwamica capsules are derived from Strychnos naxwamica plant, where that fruits are very toxic and the fruits are mixed with monocrotophos, apply for paddy to as an insecticide. But bark is known for antibiotic properties, and its bark is utilized in the homeopathic medicine for diabetes. So what my friend did, by enthusiasm, he has taken more bark and put it in the water while going to bed, and next day morning he drank that water. But here he has hospitalized, not the diabetic was reduced, because he has taken more bark. That means more quantity and more dosage. So that become the toxicity. See, when you take more quantity, our body will not accept. So it will act accordingly by vomitings or motions or so. So here I am pointing out is the plant based drugs, if you take, it has to be taken prescribed quantity and advised by the doctor, ayurvedic doctor, then only it works. Otherwise the side effects of plant based medicines only affect on your kidneys, no other organ will be damaged. That is the main important so here the Nobel Prizes, recent winners of Nobel Prize in physiology and other concepts also, medicine also, they are directly or indirectly linked to our Ayurvedic concept. For example, here the Nobel Prize in physiology in 2018 for their discovery of cancer therapy by inhibition of negative immune system. This is directly indirectly related to our Ayurvedic vata pitta kapha. And similarly in 2016 the Nobel Prize for autophagy means fasting. So it is called in Ayurveda it is called in Telugu it is called lankanalu. So that is the importance of our Ayurvedic concept or our traditional system of concept. So it has to be practiced well, and it has to be practiced well for the discovery of many leads from the plants. This is one of the classical example of very well-known classical example quoted in the Ramayana, where the Hanuman has carried Sanjeevani Bhuti, which is called a life-giving herb, brought by Hanuman to save the life of Lakshmana. Why I have quoted here this? There is a lot of life-giving herbs are available in our diversity. So the only thing is it has to be explored properly to dig out the active lead compounds to serve the mankind, and also it is also one of the good opportunity for the young stars who are taking their profession as a science as a profession, and particularly chemistry as a profession. There is a huge demand, particularly in the natural product based drugs, even now, and it is going to boost in the coming years also. So my request to young stars, please practice the natural product chemistry when you are decided to take the science as your profession. And coming to our biodiversity, the world has almost 34 mega diversity hotspot. Among them, our country hosts three mega diversity hotspot. One is Indo-Tibetan region, Himalayan region, and the Western Ghats. These three regions, and the tribal people are widely using those medicinal plants for their primary health care, and many of the plants are not even taxonomically identified, but those medicinal plants became the part of their primary health care and as well as their part of their livelihood. So this is also one of the good opportunity to explore these biodiversity areas, and where the majority of the medicinal plants are flooded in these areas to get the good leads, drug leads for the human health care. And coming to India's strength in herbal technology, around 8,000 medicinal plants are extensively used, and these are categorized as three pesticides, gums and resins, fiber, and edible plants and other species. And the contribution of the medicinal plants in the herbal technology in the systems of medicine, Indian systems of medicine, here more than 900 species are well utilized in the Ayurvedic systems of medicine. And similarly, the more than 700 species are part of the Unani systems of medicine, and more than 600 species are in the part of the Siddha medicine and Amchi based medicine. This is a Tibetan based medicine, 250 species of medicine. And similarly, 30 species are part of the modern medicine, even though now the update for the particularly the cancer patients after going to the chemotherapy, now doctors are prescribing plant based nutraceuticals for the cancer patient instead of using the allopathic medicine. This is one of the recent development in the plant based medicine. And even till today, this in this pandemic situation, I came to know, and majority in the particularly in the Karnataka region and our Srikakulam region, tribal people, they are using some medicinal plants for the to combat the COVID also. And one plant which is called Coccolus hirsutus, that is in the clinical trials for COVID-19. And that is also taken by the Sun Pharma in association with our Ayush Ministry. It is working well, and even for dengue fever also it is also working well. And it is the for the drug development is taken by the Sun Pharma. Even we know pretty well, even till today papaya leaves are the best medicines for the platelet aggregation of dengue patients. So that shows the importance of the plant based medicines. And when you see the how many drugs derived from the natural sources, so here I have taken the year 1981 to 2014. More than 1542 drugs were derived from in this period. So these are derived directly or indirectly from the natural. That is means pure natural products, either pure natural products or chemically modified natural products. Because some natural products are having some drawbacks like low bioavailability and moderate activity. To enhance the activity or enhance the bioavailability, so those natural product leads were chemically modified to increase the availability, bioavailability, and also activity, and reduce the toxicity. So even though they have modified, but the base is natural products. So here you can see this one. Only this 10% flora has been explored till date. The remaining 90% of gold mine in the biodiversity flora of different regions of our country has not even touched upon, and also not even explored. This is also one of the big opportunity for the youngsters to work on this area. And similarly, when coming to fungi, even though 3 lakh fungi species are available, only less than 1% has been studied. And you see the contribution, 61% of 877 small molecule new chemical entities introduced in this period as almost contribution is 78% antibacterial drugs and 74% anti-cancer drugs and 47% are anti-hypertensive drugs. So still amphotericin B, which is called as a gold standard, and lipopeptide caspofungin, is these two drugs are very famous in the antifungal therapy. These drugs are derived from natural products only. There is no alternative. And here I have listed few drugs which are derived from the natural products, and world's best selling pharmaceutical derived drugs, enalapril, dicyclophenac, and all those things. And categorization of the herbal medicines based on the quality, these herbal medicines are categorized to the 4 categories. Category 1, category 2, 3, 4. And category 1 is herbals for community or regional folklore use, folklore medicine. They do not have any quality control data, anything. So those medicines will fall under category 1. Category 2, documented herbal medicines like our Ayurveda medicines. They have some quantity of quality control data, and all these category 2 medicines are prepared from by following the pharmacopoeias, Ayurvedic pharmacopoeia or other pharmacopoeias. Category 3 medicines, modified herbal medicines like polyherbal formulation, and some amount of safety and efficacy data required. So then only those medicines fall under category 3. Category 4, imported herbal medicines. those are should be registered in both countries, and definitely there should be a toxic safety data, toxicity data, and efficacy data required. Then only those fall under the category 4 medicines. When you see the herbal drugs utilization in international healthcare, in not only India, many countries are utilizing the plant-based medicines. Of course, different names, not the herbal medicine, but here developed countries and developing countries, more than 40% people are based on their primary health care, and it is also the economy, also huge economy, and in the economy also escalating by year by 20 to 30% in the herbal industry. Why natural products are working on different drugs? Because natural products contains primary metabolites and secondary metabolites. Of course, primary metabolites are important to their own for their own, for the development and their the survival. Those are examples are proteins, carbohydrates, and lipids and nucleic acid. These are essential for the organism to evolve, and also these primary metabolites also sometimes responsible for the formation of secondary metabolites. But however, most of the times and most of the traditional systems of medicine contains secondary metabolites, but in very rare cases, those are primary metabolites also part of these systems of medicine. Secondary metabolites, these are very important type of metabolites which evolved through the defense mechanism, and these are highly useful for the organism protection and defense against herbivory and other interspecies mechanism. These are the list of examples: different nitrogen containing compounds, phenolic compounds, and terpenes. Here I have quoted few: nicotine, morphine, cocaine, caffeine, glucosinolates, and phenolic compounds are very well known as nutraceuticals because of their rich antioxidant activity. And terpenes, limonides, saponins, pinene, camphor. We know about limonides. Our neem tree is the richest source of limonides, and very well known as a insecticidal property, that is azadirachtin. So just I would like to quote few classes of compounds, the secondary metabolites particularly. Majority of these compounds belong to one of a number of families, each of which have a particular structural characteristic arising from the way in which they are built up, that is nothing but biosynthesis pathway. So plants synthesize the secondary metabolites through their own biosynthetic pathway of different type of compounds: polyketides, and fatty acids, terpenoids and steroids, phenylpropanoids, alkaloids, and specialized carbohydrates. So when you see polyketides and fatty acids, these are formed by the linear combination of acetates, that is called ethanoate, and units derived from building block called acetyl coenzyme A. Similarly, terpenoids and steroids, these are assembled from the nature by isoprene units derived from the isopentyl pyrophosphate. These C5 units are linked together in a head-to-tail manner. They have the characteristic branched chain structure. Similarly, phenylpropanone, these are the oligomers of C6 and 2C3 units. And amino acids, these are building blocks of peptides and protein. Although amino acids are normally considered as a primary metabolites, there are some unusual amino acids that are of restricted occurrence. Some antibiotics such as penicillins are formed from the small peptides. Similarly, alkaloids, these are structurally diverse group of natural products containing nitrogen atom. The nitrogen portion of alkaloids are derived from the amino acids such as ornithine, lysine, tyrosine, and tryptophan. Similarly, sugars. So these are the just to give structures: polyketides and phenylpropanoids, aromatic ring, and C3 unit. And terpenoids and steroids, there are different types of terpenes based on the number of isoprene units. Monoterpene, 2 isoprenes, contains C10 carbon. Similarly, sesquiterpenes, when it contains C5, 3 isoprene units. Diterpenoids, 4 isoprene units. Sesterpenoids, 5 isoprene units. Similarly, triterpenoids, 6 isoprene units, C30 carbon. Similarly, carotenoids, 8 isoprene units. So these are the famous triterpenoid structures: triterpene, alpha amyrine, and beta cytosterol. These are very common terpenoids and steroids found in many of the plants. Similarly, phenylpropanoids, the recognition of that many natural occurring aromatic compounds possess 3 carbon chain attached to the ring led to them as a popular phenylpropanoids. Best example is coniferal alcohol, photophyllotoxin from the Ayurvedic drug Phodophyllum MOD, and is an important cytotoxic agent. So these are the structures of phenylpropanoids, C6 and C3 unit, similar parahydroxycinnamic acid, amylopyrrone, photophyllotoxin. And alkaloids, it is a pretty well-known compound, and this ability to form salts to complex with other metal ions helped their separation and detection in the era before chromatography. These are the famous, very well-known alkaloids, brucine, strychnine. And when you see the evolutionary techniques, evolved techniques in the natural product chemistry from the ancient times, I think 1800 centuries to till date, even the 1800 century, there are no NMR techniques, analytical techniques are available at that time. But even though the characterization, majority of the most of the times the characterization of the compounds was done based on their physical characteristics, melting points, and all those things. So keep on moving to the 19th century, few chromatography techniques are available, similarly technique, NMR, and all those things. So in this present scenario, this huge analytical revolution, q whatnot, you can also derive the structure of the compound with few milligram, not even microgram, by using NMR data and all those things, and even mass spectrometry techniques also available, QTOF, MS, and all those things. Even smell is enough. Compounds, very low compound is enough to get the molecular weight of the compound, and also to know the fragmentation pattern of those compounds to get the structural information. If you see the success history in the natural products in the early 1800 centuries, advances in scientific knowledge at that time led to the first discovery of morphine, quinine, and colchicine. Based on these isolations, and the aspirin was the first semi-synthetic drug commercialized in 1999 by Bayer. And coming to milestones, and the penicillin was discovered in 1929 from penicillin notatum. So based on this discovery, many of the antibiotics was followed in the between the 1940 to 1970. In this 30-year span, many of the antibiotics were discovered. Examples are tetracyclines, streptomycins, and doxycyclines, and lipopeptides. That's why this 30 years period is called golden age of antibiotics. When coming to marine, in the 1970s onwards, the huge intensive investigation was done in the marine environment, and that's what resulted many of the anti-cancer drugs are available in the present market, and other drugs were derived from the marine organism, marine flora and fauna. And there is a this is the slide represents about the drug discovery from the natural sources, and there are different steps involved starting from raw material to drug candidate. Here the bio raw material, where this bio raw material has its own history in the folklore medicine or traditional medicine or Ayurvedic medicine. This may be plants, fungi, insects, marine, or microbes, and this bio raw material has been processed to do the extraction by using the different techniques available: oxalate extraction, counter current extraction, micro extraction, ionic liquid extraction. There different methods are available for the extract. After making the extract, again the activity was checked, and the bioactive extract will be taken up for the fractionation by using different chromatography techniques like column chromatography, HPLC, and supercritical fluid chromatography, membrane filtration. All these compounds, by using chromatography technique, pure compound will be isolated, and the pure compound, again the structural illustration of the pure compound will be done by the application of different spectroscopic techniques starting from UV to X-ray. And based on this structure, because many of the lead compounds are scarcely available in the nature, to do extensive biological studies, that has to be scaled up by doing the chemical synthesis in the lab and scale up process. So this will be done by the diversity oriented synthesis, and finally doing the different derivatives to identify the active pharmacophore in our lead compound. So based on the active pharmacophore, by using the medicinal chemistry and product enhancement, the clinical studies will be done. Based on the clinical studies and clinical regulatory studies, the compound may become the drug candidate. The whole time required for all these steps are more than 20 to 30 years if everything goes on well. So, and also this drug discovery process is also very costly affair. That's what many of the industries now is not taking the drug discovery aspects because of the huge investments, and we don't know whether, and even though if you invest more also, we don't know, then there is no guarantee that the drug will pass all the clinical regulatory effect. That's what even we know the last, I think, 5 or 6 years back, even though Reddy Labs also two drug candidates were failed in the clinical study, in the last stage of clinical studies. So that resulted the wastage of huge amounts. That's what many of the companies are not interested to work on the drug discovery aspects. So these are the main three steps involved in the drug discovery of natural sources: identifying the hit compound, and finally hit to lead and lead optimization. These are the main crucial steps involved in drug discovery process. When you see the role of the study of natural products today, nature still holds many secrets which we can learn from chemical structure, biosynthesis, the role and relationship of the plants to the other organisms. The study of natural products merges science with the culture, and for the countries which harbor rich biodiversity, the study of natural products is an important way of developing once in the natural resources. Natural products should use the new developments, molecular biology, computational science, and there are new techniques are available in the natural products, including artificial intelligence. That is also one of the recent approach in the natural product drug discovery. And also by application of the analytical techniques, applying the analytical techniques, we can reduce the time and we can identify the active compound without in the short time, and that is nothing but a de-replication studies by using analytical techniques. And natural products are phytochemistry activity is a multidisciplinary activity, and it's all depend upon different other expertise also, like ayurveda, folklore healers, sociology, cancer biology, taxonomy, bioinformatics, ethnobotany, neurobiology, and biochemistry. So it's a multidisciplinary activity which depended upon the different expertise, like folklore healers, because the bio raw material can be traced back from by interaction with the folklore healers. Similarly, ayurveda is also one of the important expertise to give the good knowledge about the medicinal plants to work on the phytochemistry aspect. Similarly, taxonomy to identify the proper identification of the plant, this is also one of the important aspect in the phytochemistry activity. Similarly, ethnobotany, neurobiology, biochemistry. So, of course, there are a lot of issues and challenges in the natural products today. The loss of biodiversity and IPR, intellectual property rights, patent protection, and Western drugs, high cost of drug development, new drug leads and targets. And coming to herbal products, there are a lot of regulatory aspects are involved in this herbal products, and the quality control is also one of the biggest challenge in the herbal drugs. So the priority areas in the natural products today: structural elucidation is the heart of the natural product expertise, and metabolomics and synergy and biotransformation are the good expertise in the natural products area. Similarly, molecular biology and biotechnology, and also quantitative natural product chemistry. This is related to analytical chemistry related. So this is one of the hard area in the natural products expertise. So if you work on the analytical aspect of natural product chemistry, huge opportunities are available in the pharmaceutical industries and other industries, because plants containing many number of compounds. So if you can able to develop the method for the separation of all those compounds, then it will be pretty easy to work on the synthetic drugs, because synthetic drugs may contain very less compounds, maybe the impurities of starting materials 2 or 3 or 4 or maximum 10. So if you work on the method development part of the plant extracts, so it will be pretty easy to develop the method for the synthetic drug, or to develop the impurity profile of synthetic drugs. So even though there is a huge decline of the natural products taking as a profession, and there are different aspects, because plant taxonomy nowadays, the taxonomy is also very rare, and the quality control of the plant material, because plant material and plant secondary metabolites in the plant depends upon the season wise and also area wise and country wise. For example, if you take the plant from the Khammam region and if you work out the plant in the Himalayan region, there is a huge differences in their pattern, because in the Himalayan region, high altitude and low oxygen, low temperature, which influences the plant to make the secondary metabolites through the biosynthetic pathway differently. And similarly, in the Khammam region, low altitude and different temperature also influence the plant to different to synthesize those compounds differently. So plant profile of two different regions are completely different. That also influences the formulations where these two plants are part of those formulation. That's what nowadays the herbal drug companies are analyzing the medicinal plants rich in lead compounds, and in the areas, those are surveying those areas, and they are taking the lease of those lands for the cultivation of those medicinal plants on their own. So, 1 minute. చెప్పండి వస్తున్నాడు పంపించండి జాయిన్ అవుతున్నాడు రైట్ ఓకే sorry. So that is the main importance. Similarly, the natural products expertise and phytochemistry expertise needs a lot of patience, and for the isolation of the compounds involves uh, uh, many times purification by using different chromatographic techniques, by developing different mobile phases, and and also it results the publications and all those things very lately. So this all influences the students particularly to for the declining of the this expertise as their profession. And of course, now my view is natural product chemistry is the mother of the chemistry, where I can say more than 90% of the drugs were discovered are in the present market are discovered directly, indirectly from the basis of the natural products. And also from the all sciences, chemistry is the mother of all sciences. In particular, natural product chemistry is the mother of all chemistries. So these are different extraction and analytical techniques. Just I will give a glimpse on 2 slides. So extraction techniques: solvent extraction, hydrodistillation, oxalate extraction, supercritical carbon dioxide extraction, recent technique, and refluxing. So and similarly, spectroscopic technique involved in the characterization of the compounds, mainly NMR. Of course, 2D NMR and all those studies are available for the extensive characterization of the compounds structures. And of course, IR and other studies, other techniques also available to know the functional group, presence of the functional groups in the compound. And other mass techniques, there are different mass ionization techniques are available: EAMS, ESIMS, and fab mass, and Maldi mass. So based on the compound nature, these techniques are applicable for getting the molecular weight or molecular ions or molecular fragmentation of this compound, mass fragmentation of those compounds. So these are the different approaches in the natural products area: bio-guided isolation procedure, and reverse bio-guided procedure, and NMR or mass-based approach. This is also known as de-replication approach for target identification of lead compounds, and metabolomic based approach. This is also one of the famous approach and the recent approach. And molecular networking based approach, this is a recent approach which is quietly parallel to our the artificial intelligence. So where there is a library of natural product leads. So when you do analysis, when you develop the mass fragmentation pathway or mass fingerprinting, then that is directly linked to that library. So where you will be able to identify those known compounds, unknown compounds immediately. So based on that, you can target unknown compounds and work on for the isolation of the compounds, targeted unknown compounds. So when you see the technology drivers in the natural product chemistry, of course, traditional knowledge, folklore medicine, pyrogenetics, serendipity, these are the major backbone for doing the extracts and high throughput screening for different targets and dereplication techniques available of LCMS, HPLC, MALDI-TOF, and for purification of the uh, structures and purification and the structural elucidation, finally optimization development. And recently the 3D NMR techniques also available in the recent times for the structural characterization of the compounds. Here I gave one reference where they have characterized this peptide structure by using the 3D NMR technique. So just I would like to give some of the examples, famous drugs which has been derived from different natural products. So first one is artemisinin, very well-known anti-malarial drug. And for the discovery of artemisinin, Professor Yo-Yo Tutu, Chinese-based professor, she shared a Nobel Prize in 2015. So this is isolated by Professor Yo-Yo Tutu in 1972 from the Chinese medicinal plant called Artemisia annua, and the extraction was done with diethyl ether in low temperatures. And this plant is selected for the study based on the knowledge processed from the ancient Chinese systems of medicine. And artemisinin is a structurally highly oxygenated sesquiterpene lactone containing a trioxane ring system with an endoperoxide bridging. This compound was found very effective against chloroquine resistant malarial parasite, and it kills parasites during early stages of its development, which is responsible for unprecedented success of this compound. And based on this artemisinin, several other derivatives also developed by the chemical modification of those parent artemisinin, and for different selectivity and different enhancing the activity. So here artiflin and artether and artemether, these drugs also available in the present market for different anti-malarial treatment. Similarly, Taxol, very famous anti-cancer compound. And this Taxol was isolated from the bark of the Taxus brevifolia and named in 1967. And the antimitotic inhibitory activity of Taxol was discovered in 1967. And when it was commercially commercialized to Bristol Myers Squibb, the generic name was changed to Faclitaxol. And Faclitaxol is now used to treat patients with lung and other cancers, and currently it is approved for by FDA and other agencies for treatment of different cancers in different years. 1998 with the combination of drugs cisplatin, platinum based anti-cancer agent. Similarly, first line treatment for non-small cell lung cancer 1999, and other cancers also in 1997. However, the Taxol is very scarcely available in the plant, but to serve the mankind, it has to be in the large scale produced by the industries. For that, what they have done, this becardin, this hydrolysis compound of this is called T10D-acetyl becardin. This is called shortly 10D-TAP. So this is available plenty of amount in the plant, and by taking this main compound, this tail is synthetic source is this tail is attached to this OH2 for the total synthesis of this Taxol. Even till today, this is the only procedure for the production of the Taxol industrially. Similarly, vincristine and vinblastine, very famous anti-cancer drugs. These two well-known vinca alkaloids are derived from Catharanthus roseus plant, also known as Vinca rosea. Both vincristine, vinblastine are dimeric indole-indolin alkaloids in which the catharanthine ring system is connected to indolin ring. And these are widely known agents for chemotherapy, and these are approval by FDA. Vincristine 1963 and Vinblastine 1965. These compounds are well-known anti-cancer agent by inhibiting the tubulin polymerization by binding the beta-tubulin heterodimers. And Catharanthus roseus is widely used treatment for diabetes in various traditional systems of medicine. So based on this vincristine and vinblastine, several derivatives by chemical modification has been developed, and also those derivatives are presently in the market for different anti-cancer treatment. So windacin, the first semi-synthetic analogs of vinblastine entered in the market treatment for lung carcinoma and breast cancer. Similarly, Vinrolbin is another semi-synthetic derivative of vinblastine, got approval in 1989, treat non-small cell lung and advanced breast cancers. Similarly, fluorine-containing derivative. This is a vinfluorine in the market in 2009 and used in the metastatic treatment of bladder cancer. And similarly, other compounds, other natural product drugs, camptothecin, very well-known anti-cancer agent. Similarly, photophyllotoxin. Camptothecin was discovered from Campothecia acuminata, a plant which is native to China, and photophyllotoxin is isolated from Photophyllum peltatum gums in the 1980, and the structure was confirmed in 1950. You can see the number of years they have taken for the confirmation of the structure. So, and similarly, photophyllotoxin is an aryl tetralin lignan. Is a structurally aryl tetralin recruitment. ఆనంద్ ఉంటాడు ఆనంద్ కలువు ఆనంద్ కలువు ఓకే సో సారీ two important anti-cancer drugs were derived from photophyllotoxin and approved by FDA in 1996, etoposide and tenofovir. Similarly, as I told you, there are different quality control aspects involved in herbal drugs. I would also like to touch upon those quality control aspects. See, the therapeutic activity or therapeutic effect of medicinal plants are due to the presence of the biological active chemicals, which are mostly secondary metabolites such as alkaloids, glycosides, saponins, coumarins, flavonoids, and terpenes are so. So 75 to 80% of the medicinal plants required in traditional medicines collected from the wild source, sustained supply of quality control raw materials is therefore difficult. So if you see the profiling or conscience of the plants which are from the wild source and which are cultivated source, these two contains a little bit different profiles, because wild source is a free source and our cultivation is a it's like a restricted source. So, and similarly 35 to 40% of the medicinal plants used in traditional medicines are cross-pollinated species. Hence there exists a vast intraspecific genetic variability with respect to their morphological and chemical constituents, and the heritability of these compounds are controlled by variety of factors, genetic factors, microenvironment, season, stage, growth and development of the plant. As I mentioned you earlier, the plant constituents or plant metabolites or secondary metabolites are completely depend upon their stage of the plant, and similarly growth and the environment and also temperature. That's what, if you see the profile of the medicinal plants of different regions and different stages, like early stage, middle stage, and the ripened stage, unripened stage. So definitely there will be a small variation. So when you doing the formulation of those plants, those plant metabolites has to be standardized by quantity and quality in different seasons and different locations and different temperature. So it has to be standardized before taking that plant into the formulation. Then only those formulation is called as a quality controlled approved formulation. And the lack of written documentary evidence on the clinical efficacy and traditional medicines, more particularly Ayurveda, is essentially highly customized and individualized medicine. Transformation into generalized and commercial system has adversely affected in the system. And the lack of consistency in the quality in batch to batch production of the products, and the lack of well refined, well orchestrated SOP. So when you see, when you take the Dolo 650, that is paracetamol 650 in the any medical shop, irrespective of the company production of the company, the dosage is 650 mg only. But it's not happening in the herbal formulations. That means the quantity of the lead compound or active compound is not the consistence in the different batches. That's what sometimes it's working, sometimes it is effective, sometimes it's not effective, and sometimes it may be the it may also become the adverse, give the adverse effects. So it's all based upon the the lead compound or marker compound which are present in the formulation. So we are also working in this direction in the standardization of the herbal drugs by using the advanced analytical techniques HPLC and HPTLC, as many of the agencies are now pressurizing the herbal companies and pharmaceutical companies to get their fingerprinting profile before approval. So these are the different stages involved: quantity, quality, adulteration, and efficacy. This has to be checked out for the standardization aspect. So and these are the different aspects checked: physical, chemical, biological, botanical. And when physical aspect, the moisture value, ash value, extract value has to be checked out. And in the chemical, the raw material should be free of pesticidal residue and free of heavy metal residue. And biological aspect, the plant material should be free of microbial contamination, and pharmacological evaluation, toxicology studies should be done for the extracts. And when botanical, there are number of plants which are synonymous to each other. And what the herbal companies are doing, when the original plant is scarcely available, then those companies are utilizing the plant which is synonymous to the original plants. So in that aspect, that formulation may be effective or may not be effective. And sometimes if the synonymous plant is not safe, or it may be the toxic also. So sometimes the adverse effects will also be happened with because of the synonymous plant. So in that aspect, the plant has to be characterized by using the microscopic and macroscopic techniques. So these are the advanced analytical techniques approved by the FDA for the checking of the characterization of the herbal medicine: HPLC, HPTLC, UPLC, LCMS, and GCMS. All these techniques has its own advantages for the analysis of the marker compounds or characterization of the herbal medicines. So I would like to give one of the example of our work. So here the plant is called Sasuriyalappa, which is a very well-known plant available in the northern part of our country. And these two are the marker compounds. So what we have done is we have procured that plant and quantified these marker compounds from this extract, and by developing the HPLC method. And further, we also purchased some of the formulations where this plant is part of these formulations, and analyzed whether these formulations containing the marker compounds or not. Because if if they contain marker compounds, then these are the good formulations, or otherwise these are adulterated formulations. By using our HPLC method, we analyzed these formulations for the marker compounds. Fortunately, those formulations are containing the marker compounds, these two compounds. And further moving ahead, we also studied the stability studies, because our intestine contains acidic environment and other environment. If the marker compound is not stable enough in the acidic environment, for example, if it is converted into other compound, the other compound may be toxic or non-toxic, we don't know. If it is a toxic, then we are gone. If it is a non-toxic, then we are safe. So for that, we also conduct the stability studies. Fortunately, these two compounds are stable enough in the stressed environment. And I would also like to share one example. I think 4 or 5 years back, one of our senior colleague was superannuated, and he was at that time he was suffering from arthritis, which is a age-related disease. By old age, almost most of the Indians will be suffered from the arthritis or this one. So he's a basically Maharashtrian. So when he went to his native place in the holidays, he has been advised by his neighbors or his maid, sir, you can use this plant-based formulation, which is working very well on the arthritic pain. You will get relief like anything. So he used that formulation for a couple of weeks, for 14 days course, or like one course. So he got very good relief. And then generally we do our health checkup, our own dispensary. So when he went to our dispensary doctor, he mentioned the same thing. Sir, I am using this herbal formulation, and I am getting very good relief when compared to our medicines. So what can I do? So he got a doubt. Then since I am working in this field, and he called me, and and to analyze for the analysis of those herbal medicine. I have analyzed those formulation. It contains lot of steroids. So I conveyed the same thing to our doctor and our colleague. So again, he used, he went to some Unani doctor, Hyderabad based Unani doctor. Again, he got very good pills colored with green color. And he has used that same pills for course like 14 days or 10 days. So this time also he got very good relief, and he came to me for the analysis. This time I analyzed those Unani pills for the presence of steroids, but fortunately those Unani medicine did not contain any steroids. And moving ahead, I have developed the HPLC method for to know about the components which are present in the this one. So surprisingly, that Unani medicine contains 80% of diclofenac sodium. So what Unani doctor did, he has purchased diclofenac sodium from the market. He made a powder, and he just added some leaf extract to get impression this is a Unani medicine, herbal based medicine. So these type of adulterations are common, are pretty common in the society, but we should be very careful while taking those herbal medicines. So that's what this is one of the biggest drawback, quality control drawback in the herbal medicines. And majority of the herbal medicines works in the synergistic pathway, like it's like a team effort. So all the, because when you take the antibiotic, allopathic medicine, you will always take B complex tablet or other tablet. But in the herbal medicine, that extract or herbal medicine contains one active compound which is supported by the other compounds. No need to take any antibiotic or like that. So some compounds act as a nutraceutical, some compounds work as a drug candidate. So that is nothing but a synergistic effect. So just I would like to emphasize some of the compound drugs derived from the marine organisms. We know pretty well our country has a long coastal region of different environments. Here you can see the different, here sea is surrounded by the hill and the plain sea, and sea between the hills. This also affects the marine flora and marine fauna to synthesize the different type of compounds. So the sources of marine drugs, majority of the marine products have been isolated from sponges, tunicates, and molluscus, echinoderms, bryozoans, and wide variety of marine organisms in their tissues. So these are the pictorial representation of sponges, molluscus, tunicate, bryozoa. And many of the marine compounds, marine secondary metabolites evolved from defense mechanism. So what happens, for example, one animal named marine sea cucumber. Sea cucumber daily travels mostly 100 meters. So when sea cucumber is surrounded by the enemies, it sprays initially, immediately some synthesize some chemical weapons and sprays to the enemies to protect itself from the enemies. So this is nothing but the defense mechanism. During the process of defense mechanism, so sea animals and the other sponges also synthesize novel type compound. That's what, when compared to organisms available on the competition for survival and also environmental pressure, because this is called biodiversity. And because of the large type of organisms available, every animal, every organism has to protect itself from the other organisms or other animals. This is called defense attacking signaling, as I mentioned in the example of sea cucumber. So while in the defense mechanism there is a huge chemical diversity and synthesis of different type of novel compounds which finally act as a potential new drugs. So many marine organisms are soft bodied or live a sedentary lifestyle, and a necessity of chemical means of defense. and evolution of ability to synthesize toxic compound, and many natural products from these organisms act as a chemical weapons and are highly potent inhibitors of physiological processes in prey, predator, and competitor. Several show pharmacological activities and are effective against cancer, AIDS, arthritis, and highly potent. So I would like to give some few examples. This is the first example, giconotide. Uh, don't scare by seeing the structure. And this derived from the toxin snail called Conus magus. Is the first drug of marine origin obtained approval by FDA in December 31st, 2004. And it is the most powerful painkiller known to date. And this is another drug, holicantrin B, important drug. This is a holicantrin B was isolated from this sponge, Holicantria wacadea. Holicantrin B was discovered in the marine sponge in 1985, and it is showing moderate activity of anti-cancer activity, particularly breast cancer. So by doing this, the chemical modification, that is here the truncated, here the hydrolysis of this ester bond, they have prepared the synthetic analog of this holicantrin B called erubulin. This is a highly potent toxic agent, acts through indicating the microtubule growth by binding with it. This is a till date, this is the most effective drug against the breast cancer, and recently this has been marketed through the trade name Halaven B. It works. This injection almost costs as in the USA it is around 5,000 US dollars. And now in the Indian pharmaceutical companies are working very seriously to synthesize this complex molecule, and it is marketed in the 2010. Similarly, in the other compound, bryostatin 1, which is isolated from the marine bryogen, Bagula nertian, and it modulated cell signaling enzyme by PKC activity, and it is approved for different cancers individually and also in the combination of other cytotoxic agents. And these are the other drugs of different targets, antiviral, anti-cancer drugs, and antifungal candidates, antiviral drugs. Here I have listed where these all are derived from the marine sources of different marine flora, marine fauna. And another unexplored natural source is lichens, where the lichens are symbiotic organism with algae and cyanobacteria, and these are also called chemical ecological indicators, where these lichens grow in the moisture and non-polluted areas. Lichens also has a history of their utilization in the ancient times. So lichens also having all the activities where the marine compounds and plant compounds have. Of course, there are no lichens drugs are available till date, but of course the lichens are utilized or added in some of the drugs in the market, particularly in the cosmetic drugs. So when you see the lichen rich, particularly lichen grows in the non-polluted areas and moist areas, Western Himalayas and Eastern Himalayas, and in the middle region and Eastern Ghats, Western Ghats are the richest source of lichens. And here the Rayalaseema forest and Nalamala forest are the good areas for the lichens. When you see the state-wise diversity, Tamil Nadu is the richest in the lichen diversity, and followed by the other states. When coming to our own activity, natural product research activity at IACT, as I am working in this area from the last 20 years or so, starting my PhD. So after coming this field, we regularly interact with the tribal people to know their knowledge regarding the folklore medicines and all those different extracts for different targets in the interior forests or interior tribal people or interior areas of our state, AP and Telangana, and also in the northeast region. So we will we will interact by interacting. We came to know some of the medicinal plant. So we will pick up those medicinal plants for the isolation and characterization of those active compounds, and by after isolation of these lead compounds, chemical modification studies will be done to enhance those activity and to make that lead compound as a clinical drug candidate, and followed by the SCR studies. And in the applied side, as I told you, we are we are taking a lot of the projects from the industries for the standardization of the herbal drugs, marker compound based standardization, and also process development of the active compound from the crude extract, and other projects funded by different industries and other components. So this is the new drug discovery aspects going on at our IACT, and this is our approach. We do work on different natural flora, medicinal plants, marine and lichen species also for the discovery of lead compounds and other studies. So based on the activity, the compounds will be patented and it will be taken forward to make it as a drug candidate. And finally, I would like to once again thanks for organizing committee for having me in this international webinar. And I would also like to thank to director Dr. S. Chandrasekhar for his enormous support, and Dr. J. Madhusudan Rao, who is my supervisor. Because of his blessings only, I was in this unique field of expertise, natural products, and and other funding agents, DST, DBT, ICAR, CSR, for their financial support to work on this area, and not least my students, because of their hard work, and I am able to be in this position. And once again, I would like to thank my students for their attention and their for their hard work. And here I would like to mention about the IACT. IACT has established before India's independence. Last year, IACT has finished its 75th birthday, and we have different areas of research, starting from catalysis, genetic chemistry, synthesis of drug intermediates, fine chemicals and agrochemicals, pheromones, and natural product chemistry. And we have national state of art facility of analytical equipments, XRD, and different chromatography, HPLC, and all those things. And these are the pioneers of Indian scientists who are pioneered in the natural product chemistry in their entire life. J.L. Simonson, Ramnath Chopra, Shilaman Siddiqui, T.R. Sheshadri, K. Venkatraman, T.R. Govindachari, known for neem scientist, Asima Chatterjee, Shashank Chandra Bhattacharya, and Sukhdev. He is a living legend of our natural product scientist. He is very well known for Google steroids. And once again, thanks for giving the opportunity and your patience. Thank you very much.
Thank you, sir. Thank you very much for sharing your insights with us. And there was so much valuable information in your presentation. Once again, thank you, sir.
Thank you very much.
So now, this is the time to gain the strength of the next resource person. For that, I would like to invite Professor Wazira P. Bulgopitia, Department of Chemistry, University of Rwanda, Sri Lanka. On the topic, diversity and ecological activities of halogenated secondary metabolites in populations of red algae, genus Lawrencea in Borneo. I request Dr. C.H. Srinivasalu, Head of the Department of Zoology, to introduce our resource person.
Thank you, madam. Good morning. It is my privilege to invite Professor Wazira P. Bulgopitia, who has been one of the pioneer natural product chemists in Sri Lanka, former head Department of Chemistry and present director, Distance and Continuing Education Unit, University of Rufana, Sri Lanka. She graduated from University of Rufana, Sri Lanka, and obtained her PhD in organic chemistry from University of Freiburg, Switzerland in 1999. She had been serving academia over 28 years in teaching and research in organic chemistry, with main focus on natural products and pharmaceutical chemistry. Her main research area are natural products based drug discovery, development of functional foods and nutraceutical from natural products. Sri Lankan fruits and rice varieties to be used in human well-being to combat non-communicable diseases. She authorized over 60 publications and conference proceedings, national and international, in these fields of research, and honored with several fellowships, such as Commonwealth Fellowship, UK 2013, Matsumiya International Fellowship, Japan 2008, NAM Fellowship, Pakistan 2007. She is the principal investigator of new research grants, and in 2019 received a huge grant of 40 million SLR to develop multi-targeted, multi-functionalized nutraceuticals and functional foods to fight against prevalent non-communicable diseases. Thank you so much, madam, for accepting our invitation. May I now request you to share your research, rich experience in the field of natural products and address the gathering. Thank you.
Thank you. Thank you for inviting me to be the resource person in this your webinar series. I especially thank to Dr. Ramesh for organizing committee inviting me to be the resource person, and also Dr. Suresh Babu. He's from CSIR Institute, because he's the one who introduced me to Art and Science College. So I congratulate you all for to have a very successful webinar series. So, and wish you all the best. So I will share you some recent advancement of natural product research. So I hope I can share my this. Yeah. Can you see my slides? Hello. Can you see?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah, madam.
Yeah, okay. So I'm talking about the emerging trend in natural product research, especially functional foods and nutraceuticals, as a measure of reduction of the risk of non-communicable diseases. So as we all know, natural products, those are produced from living organism. So they categorize or name as phytochemicals and possess great structural diversity. And with that structural diversity, it shows functional diversity, especially biological function, diverse biological functionality. So there are many categories of natural products based on their structures. So as you all know, some I have mentioned here, like alkaloids, terpenoids, saponin, steroids, so many more. So those are categorized because of based on their structure. So we have been using natural products day-to-day life for our health care purposes, disease curing purposes, and also many other cases like herbicide, pesticides, many of applications. Yes, as the previous speaker, Dr. Suresh Babu, clearly described all these things, how these medicines are derived from natural products. Most of the medicine we are using are derived from these natural sources, especially from plant, and might be developed because of the development of the science and technology. Before that, in the past, people have been used since very past with human civilization. People use this plant used for their healthcare purposes, health promoting purposes, disease curing purposes. But the science has not been developed that either. In 1804, morphine has been discovered or extracted from opium. So this is the, and after that, the scientists, chemists, people came to know that active principles, because the opium is used for those purposes, but active principle was not known. So with that, active principle has been identified. So with this one, with many more active principles from medicinal plant have been discovered throughout centuries. And now we know that many thousands of, and we are using those compounds directly as a medicine, with some formulation as well. As Dr. Suresh Babu mentioned, yes, we are in world flora, even in Sri Lanka, we are with very high biodiversity, in India as well, but in the world as well. But still we have not explored all the flora, at least not 90%, it's only 10%. That means we have still large avenue, large opportunities to explore this flora, to discover novel compounds, new active compounds, new applications.
Ma'am, voice is not clear.
For human well-being. Hello? Hello? Can you hear me?
Yes, ma'am. Clearly, ma'am.
Yes, you are audible,
Hello?
ma'am.
Can you hear me?
You are audible, ma'am.
Yes, ma'am.
Audible, ma'am.
It's not hearing.
Class ma'am.
Hello?
Yes, ma'am. Now it is audible, ma'am.
It's not clear to me. Can't you hear me, or can you hear? Is it clear? It's not clear.
Please proceed, ma'am.
Clear,
It's
ma'am.
clear
Clear,
only.
ma'am. Please carry on.
Okay. Yes. The natural, as I mentioned, this plant has many of the bioactive compound, active principles. Some of the active principles have been isolated and identified, and their pharmacological activities are known. But if we consider this plant extracts or plant, it contains not one compound, it's a many, maybe 100, 200 or many compounds. So when we use plant extract as it is, or plant as it is, we can expect that additive effects or synergistic effects. So that's what we experience in herbal medicine, traditional medicine, Ayurvedic medicines. So they use that synergistic effects as a medicines in that traditional medicines, like not in Western medicine. So that is very important things when we use herbs, natural products for our healthcare purposes or treatment purposes. So because with the synergetic effects, so because as a plant compound, individual compound may have different pharmacological activities. So then this all together, it may give activity but we do not expect, but it can be a beneficial effects and reducing unwanted effects. Inside that mechanism may be working to reduce the unwanted effects but improve the beneficiary effects. So as we know now, so we are very much suffered with these non-communicable diseases all over the world. Especially that is severe in low and middle income countries like us, India and us. And so you know that what are those diabetics, cardiovascular diseases, cancers, many more. Right. According to that WHO, 41 million people died from NCDs, which is equivalent to 71% of total death. Each year, about 15 million people die due to these NCDs, especially this age 30 to 70. This most of the premature death related to this. Even now, we know that we all are very much suffered with this COVID-19 pandemic, but most vulnerable people are the people who are suffering with these non-communicable diseases. So whatever the technology advancements, science, the research advancements, they are still, we are not able to manage this non-communicable diseases, the risk of non-communicable diseases or number of deaths due to these non-communicable diseases. So because of that, it is better we move to the preventive measures, not the curing measures. Because curing is, we have experience now, the curing is most difficult, right? So we are having large natural source with biological active, pharmacological active compounds. Why we cannot use those to prevent these non-communicable diseases? So we have to actually now the natural product research has moved to that directions, and the natural products now we need and directions, but we need to develop more into that part of the research. That means how we can use science and technology to get out this natural compound to work to combat these non-communicable diseases or to prevent the risk of these non-communicable diseases. So if we consider, if we think about why this non-communicable, what is the cause for this non-communicable diseases? There are many causes like environmental, diet problems and genetic problems. There are so many causes, but what is the biological situation in NCDs? It is known that the oxidative stress generated in our cells, not excessive oxidative stress, we call it as a excessive stress generated in our cells, make this damage to our lipid, proteins, DNAs, to move on to these non-communicable diseases. So due to this oxidative stress, high oxidative stress, some free radicals generated in our cells. Free radicals generated in our cells in normal biological functions, but some free radicals are generated in excessive amount. Some unwanted free radicals are generated. Then these free radicals attack on our biological molecules. So then it change all our biological functions, biological reactions, then it leads to make many abnormalities and causing these NCDs. So if we can disturb that process, if we can disturb this generating of free radicals, or if we can quench these free radicals before doing damage to our cells using our natural products, then we can use it as a preventive measures, right? So that I want to talk is that. So this can be, that means the key target now to develop novel preventive therapeutic strategies to disturb or inhibit this free radical or this unwanted free radical reactions or unwanted reactions in our body using this natural compound. That, and also synergistic effects also important at that end. Yes, in this end, the neurologicals and functional foods are getting more exposed to the world. Neurologicals and functional foods as these key components to combat these NCDs. Right? So this is nutritional therapy. What is there? So nutritional therapy and phytotherapy. Both are emerged. Nutritional because we take food as a nutrition and also to relieve our hunger. And so if we combine, if we merge this food with the phytotherapy, then so we can use it as a, so we eat for nutrition, we eat for our hunger, and we eat for our health. So we can use that concept to combat this heavy burden of NCDs. So there's a strong recommend these NCDs. We know that it's not a new concept that is known for long, but now we are moving fast to that era. That means that concept, because we need to develop more and more nutraceuticals and functional foods to eat as a health promotive agents. That phytotherapy have become progressively popular and improve health and also prevent and treat disease. As you know that phytochemicals, they design in biological functions, pharmacological functions, then it can treat, even it can, when we eat, not only promote the health, but also it can treat the disease in our body. So therefore, this renowned interest of plant extracts and natural products to discover safer, lower risk products in human health perspective in natural products and food research. So what is this nutraceuticals? It contains the combined word nutrition and pharmaceutical. It has a nutrition factor, it has a pharmaceutical factor, and then combined nutraceuticals. So that means it gives the nutraceuticals beneficial effects like physiological effects for action on immune system and digestive system, and also most importantly, when we take nutraceuticals, we can reduce our intake of medicines. That means we can balance our health. We don't need, we can go away from our medicines. So many advantages we get. We improve our health, we improve our economy even. We don't need to have many money for the medicines. We don't need to go to hospitals. So then that's very good if we move to this nutraceuticals world. So nutraceutical possess multiple therapeutic effects with lacking of unwanted effects. attract more consumer interest now. Yes, so this is some more explanation for nutraceuticals. Nutraceuticals. So plants produce drugs. Then plant we use same plant for the nutraceuticals. So not drug itself, but we combine this plant compound for nutraceuticals, and then we get health benefits of prevention. So these nutraceuticals can be a dietary supplement. It can be in a liquid form, tablet form, capsule form, like we take the Western medicine. So usually it's better to be used as a dietary supplement. So that's so that is supplement. It's a liquid capsule version of nutrients found in food, and it is taken as an additional supplement to the daily diet. Yes. For the nutrition, as when we take medicines, so we need to know safety, we need to know efficacy. Likewise, nutraceutical also, because based on scientific evidences, so we want to prepare nutraceuticals. So that means we should know about safety and efficacy, of course. Otherwise, we can't eat many grams, many kilograms nutraceuticals, because so the safety and efficacy and should be aware. That means as scientists, as natural product chemists, so we have more work, more research we can do on this safety, efficacy on these nutraceuticals. So that means the efficacy means whether when we use these pharmaceuticals and so plant products, we should know whether this plant compound contain this pharmacological active compounds, and whether this plant contains some toxic compound. That means these are the natural product research. We want to elaborate more research on that. So safety, efficacy. So this is for the work for the natural product researcher to reveal those things, to find out these things, and to produce, in order to produce safer nutraceuticals. So these pharmaceutical components can be directly be a plant part or crude plant extract, or specific plant fractions, maybe aqueous fractions, or isolated compound, or volatile oil isolated, or then and also can be some compound we can prepare using biotransformation, bioconversions. Because one compound can be transformed to another compound using some biological agents like algae, fungi. It's called biotransformations. So these compounds can be used. So why these phytochemicals can have these pharmacological effects? Because these phytochemicals, as I mentioned, alkaloids, flavonoids, or those things, those compounds are already known to have many pharmacological activities, as I mentioned. For example, alkaloids are known to have anti-cancer, anti-arrhythmic, analgesics, antibacterial. There are many. Flavonoids, antioxidative effects, anti-inflammatory properties. Like those are those pharmacology activities have already been reported with this compound, and also some activities are already day to day and every day. The activities are being discovered. and saponins known to have a hypoglycemic activity, antidepressants, diuretic properties, like many pharmacological activities like glycosides used in heart diseases, and tannin also used in cancer chemotherapy as an anti-inflammatory agents. There are so many pharmacological activities already being revealed, like terpene and phytosterol, many more. So when we use herbal compound in nutraceuticals, that means we added these all the phytochemicals to our food supplement. Then we can expect this beneficiary effects, because those are having many pharmacological functions. Then we can expect it. So what we can get from these nutraceuticals? They can increase health value, help to live longer, help to avoid particular medical conditions, can have psychological benefits, and also can work against some unwanted effects. And it can also those nutraceuticals can act as substrate for biochemical reactions in our body. It can act as a cofactor for enzyme reactions, inhibitor for some unwanted enzymatic reactions, and it can work to eliminate, as I mentioned previously, undesirable compound. So it can scavenge reactive or free radicals, and also it can enhance the absorption of essential nutrients. There are many more, right? So there are many beneficial effects from these phytochemicals, and also many pharmacological effects, like as I mentioned, cardiovascular, anti-cancer, anti-diabetes, anti-obese, like many. So then, now you see, if you move into the nutraceuticals, that means some nutrient plus pharmaceuticals from natural herbs, so we can get this many beneficiary effects, many for the health promotions and also curing, because it contains many phytochemicals. So then, what is the role of natural product chemist in this research? What's the role of natural product chemist? Yes, so we can find novel herbs with potential therapeutic compound, because as I mentioned previously, as also Dr. Suresh Babu mentioned, we have already explored only 10%. There are 90% untouched. So then we can explore, we can do research on this untouched flora to find novel herbs with novel potential therapeutic compound. And also, because when we want to use in nutraceuticals, maybe it's better if we take some potential part of this plant, active part of plant, and use in nutraceuticals. For that, we want to develop efficient extraction method to extract potential part from the plant. There are conventional methods. Yes, we can advance those methods. We can discover, innovate new methods. And also, as a natural product chemist, we can develop method to isolate individual compounds. Sometimes we can use individual compounds in nutraceuticals and also as a drugs as well. And also analysis of natural product mixtures. We can develop different analytical methods. And also identification method for novel bioactive compound. That means for novel bioassay methods, to identify bioactive compound, we have to use a bioassay methods. We can invent novel bioassay method with the natural product chemist together with pharmacologist. We can develop that. And novel technologies to produce or develop nutraceuticals. When we want to use many nutraceuticals, more active nutraceuticals, more efficient nutraceuticals, so we have to develop technologies. So there are many work has to be done by natural product chemists in the concepts of nutraceuticals. Yes, if we come to extract, if you consider this, how to extract this bioactive compound extracts, what's the, we all know, what's the conventional extraction method is a solvent extraction. So this one used for many extraction purposes in natural product chemistry. So there we use solvents. Whatever the solvents we need, we can use it. So this has some advantage compared to the other methods. Sometimes processing cost is very low. We don't need to have a very sophisticated instrument. We can just do with the flask and condenser. And so this is not difficult. But there are some drawbacks in these conventional methods. So we have to use solvents. Solvents are always toxic because it's organic solvents. Other than water, all are toxic. And then once you use the solvents, we need to recover the solvents because we can't discard solvents to the environment. So of course, that is cost. So then we have to recover the solvents. Then we have to use methods for the recovery, the large amount of solvent use, and also normal extraction method. It takes some time. Because of that, we need to have innovative extraction methods as a natural product chemist to develop in this field of natural product research in order to be using nutraceuticals and also functional foods. So what are the innovative methods? Yes, there are some methods not innovative. Actually, those are some we are using since long, but we can develop innovative methods. Some alternative methods are there, like oxalate extraction, ultrasonic extraction, microwave extraction. There are, some alternative methods are available. For example, pressurized liquid extraction. This is the new extraction system. So this is accelerated method, and we use pressure, and I think it's rapid because we don't need to wait hours and hours. Right? But we need to have a high pressure, and also we need to have a high temperature. That is not very much good in natural products when we use high pressure, high temperature. And then there are some other methods like subcritical fluid extraction. So here the pressure is maintained while the temperature is taken below the supercritical threshold. So this technique has emerged as a useful tool to replace traditional extraction method. So this has advantages like it's faster and produce high yield, less amount of solvent, and also we can use water here. It's a greener method and well suitable in nutraceuticals and functional foods. And supercritical extractions, as you all know, we have to use supercritical solvents like liquid carbon dioxide. So those are having high selectivity, again short time. We can extract bioactive compound with the minimal alteration. That is also important because once you do the extraction, if we change the activities, then it is not a beneficial, it is not a effective. So we need to find the extraction method which don't change the doesn't change structural it doesn't change the structure and also activity. Okay, and so then it keeps the curative effects that go functional effects. So, but what you know is that carbon dioxide is not a high polar. So because of that, we cannot extract high polar compound in that sense. So we can use some core solvents like polar core solvents like methanol, ethanol, acetylphenol. We can do that combined extraction. That make that facilitate to extract very polar compound as well. So this is the sketch for supercritical fluid extraction. We have to have carbon dioxide. And you can find this in internet. I got this from the web. And so the next one is microwave assisted extraction. This is the we can use microwave to accelerate the extraction process. What happened that the microwave molecule absorb this microwave and this make rupture, and then the compound can come out easily. So this is like you can have a microwave, normal microwave oven, or specific way of doing that. And ultrasonic assisted extraction, that is also some recent method. And this can be applied especially in antioxidant extraction. That is very useful, this method. So providing high recovery of target compound with lower solvent consumption, and also it keep the bioactivities. So this is ultrasonic assisted extraction, but there are different, you can use just ultrasonic bar, and you can insert your plant sample in a flask and insert in the ultrasonic bath, or you can use this way. And some other modified extraction methods are discovered, like enzymatic treatment, instant control pressure drop extraction. Why this enzymatical treatment? Yes, sometimes you know that whatever the extraction method we use, there are some part of the compound which cannot be extracted. Those are bind to that matrix. In that sense, we have to take if we want to take all these things out, we have to use some innovative methods. So their enzymatic treatments are like that. We can increase the amount, or we can take the compound which cannot take from the normal conventional extraction method. So because some enzymes you can use like beta glycosidase, beta gluconate, pectinase, like enzymes, because they can use to break the bonds of the cellulose and compound with this compound which is attached to this plant cells. This is also good for the antioxidant extraction. So that is also used in enzymatic assisted extraction, could be used to obtain valuable compound from the waste, especially agricultural byproducts. That can be used, because even the agricultural byproducts, food waste, there are some foods, you know, that we don't take. We take when we eat the food, we take one part, but if we discard one part. There are sometimes very good antioxidants are available with that discarded part. But then we can extract that antioxidants and we can use them in a nutraceutical, so functional food. So this type of efficient extraction method can be used here. So this is that. This is also I took from the internet web, so you can find these methods. The sketch. And there are some other methods like pressurized liquid extraction. So they also you have to use high pressure. I'm not going to talk about all these things. There have been there's a schematic diagram for that. And some other methods called instant control pressure drop assisted extraction. So here this one helps to extract volatile oil without without destroying the properties or without wasting, right? So this method we can use for the extractions of volatile, because volatile oils are very important pharmaceuticals. So we can extract volatile oil and we can use in nutraceuticals. So this method can be used for that. Because normal is steam distillation, hydrodistillation. So when you usually what we do is steam distillation or normal hydrodistillation to extract this volatile oil. But there are we lose more compound. Some compound regurgitate, some compound evaporate. So here in this method you can extract maximum without damaging the properties. Right? There are some other methods called pulse electric field extraction. Those are innovative methods. You can check these methods in the literature and you can use it. So there are some other method called pressurized low polarity water extraction. This method is very good in because we can use water to extract compound efficiently. So then this is very good in nutraceuticals and functional food. Yes, the antioxidants. So I'm not going to talk about much on antioxidants. As you know that most of now we all know antioxidants. We always look for when we eat fruits, we look what are the antioxidants, how much antioxidant we can get from this food. When we eat vegetables, we look for what are the antioxidants we can take. Why? Because we know that antioxidants are very good pharmaceuticals in our good health. To maintain good health, the antioxidants are very important. Why? Those can combat against these non-communicable diseases. That is known. So then, if we take antioxidants from this, there are food we cannot eat. For example, underutilized foods. There are some food we cannot take all over the year, right? Maybe these foods contain antioxidants, but due to some other taste or something, we cannot eat that food. But those are good source for antioxidants. There are agro waste, there are food waste. Those are having antioxidants that we can extract, as I mentioned previously, using this innovative method, and we can incorporate in functional foods. We can incorporate in food. We can prepare functional food. We can incorporate into nutraceuticals, and we can use for our health promotions. Right. So antioxidant analysis, antioxidant extractions, as I mentioned previously, you can use all the conventional methods, but not much efficient. You can use that ultrasound method is very much efficient. And then what's the next role of natural product chemist is the analysis of natural product extracts, because we want to identify bioactive compound. So there are many methods known. Chemical analysis, spectroscopic analysis, chromatographic analysis. There are many methods. And also some methods, we can invent new methods as a natural product chemist for the particular analysis, right? So this is there are so many Chromatographic methods have been developed, not like in the past. What we know in the past is only column chromatography or GC, but there are many innovative chromatographic methods like HPLC, LCNMR, LCNMR mass, LCSV, ENMR, there are many, right? So this method we can use to analyze this natural product extract. How many compounds there, what are the compounds there. Then we can compare with the databases and we can identify without going into isolation. Those things are important in development of this research. For example, this is a novel method for fine crude extracts with UHPLC POFMS. That is called ultra high performance liquid chromatography protocol time of flight spectrometry. This is a new approach to chromatographic separation for fast, high resolution. There are methods have been developed in developed world. We can, though we are not rich enough to afford those, but those are developed. Then now I come to functional food. Yes, functional food. What is functional food? That's similar to nutraceuticals, but the term functional food sometimes used to describe food and drink that are enriched with particular nutrient or substances that have the potential to positively influence health over other their basic nutritional value. So those are food. Nutraceuticals we can't take as a main food, but functional food we can use as a food. In addition to food value, it has again some beneficial effects to our health, right? For example, yogurt, drinks, breads, many things you can functionalize. You take a yogurt, but you can functionalize with natural products. That is a functional food. You can prepare drinks, you can functionalize with natural products. So then it's a functional beverage, right? So those functional food can be probiotic, prebiotics, functional drinks, functional cereal, bakery products, pets, many more, right? Why we need functional foods again? We don't need to have a medicine. We want to balance our health. We want to maintain good health. Then we can eat, same time we can manage our health using this functional food, right? To reduce the risk of this non state. Yes, to reduce the risk of illness and diseases, to maintain our health. So what is prebiotic? Prebiotic means some microorganism. We can use this microorganism to improve our health. There are some lactobacillus, saccharomyces like this, right? And what's the functions of this probiotic food? So those can improve our food digestion, our health. How? Yes, probiotic encompass wide range of bacterial strains. Probiotic must be taken regularly to serve their passage through gastrointestinal tract, because you know that most of the people having this problem in the gastrointestinal tract due to unwanted microorganisms like the bacteria. That's also main cause of many diseases. So this, if we can enrich our food with these probiotic organisms, then we can get relief from this unwanted defects, or the bacteria can come back. unwanted bacteria, right? Not only that, keep your skin healthy, glowing, eliminated yeast, like a fungal infection. You can maintain healthy weight or weight loss. Okay, you can work against the unwanted microorganism, right? So there are many good effects from this function of food, right? They reach to our intestine in life and aid digestions. With that, when it help digestions, it also make many beneficial effect to our body, because there are many people, yeah, having the problem with the digestion problem. We eat food but no digestion. So then it may many other diseases. So those things can be avoided with the food, because with these natural products we are having. Right, so those I skip because this time is passing. And then what's the prebiotic? Prebiotic means prebiotics are food ingredient. So you can't see. Yes, food ingredient that induce the growth or activity of beneficial microorganisms. This food ingredient now we in our body we can take as a food, but that help our beneficial microorganisms. So that is also better in the gastrointestinal tract, right? Common things are prebiotic like oligosaccharides, insulin, like those things. And there are functional drinks, right? There are functional drinks because we can take the drinks, we can prepare drinks enriched with this phytochemicals or plant compound to help our good health, right? So we can include some like omega-3 fatty acids. So, and there are something we can lower the cholesterol level, lower the diabetic risk, and also cereals. Many things we can incorporate. Even to the cereal, we can incorporate natural compound. And so we eat cereal, but with the we eat food, we take medicine, not medicine, but health promotive agents. Right? Even the bakery products. We take biscuit, we take breads, but in the breads we are having natural compound which help our improve our health. Right? So there are many more functional food spread, even the bread spread, we can use those. And functional egg, there are many countries they use functional eggs. That is very interesting. So what is the, yeah, there are a talk all these things with functional foods and nutraceuticals, how we can do this, how we incorporate, what's our role of natural product chemist, and then what you may get confused, what is, some may have a problem with what's the difference between functional foods and nutraceuticals. Yes, those are much similar, but in case of nutraceuticals, as I mentioned previously, we should know really the safety efficacy. And also for the nutraceutical, when we take as a food supplement, we need to, before that, we have to do the clinical test as well, clinical trials. With that, we have to, otherwise, it may, if we use that without those data, it may again can cause adverse effects. Because of that, nutraceuticals, of course, we have to know this data safety efficacy. That is the role of, as the duty of natural product chemistry along with the pharmacologist, right? But functional foods not like that. You can use it, right? What's the global nutraceuticals, global demand for these nutraceuticals and functional foods? Yes, it's a high demand. So global nutraceuticals market size was valued $, that much in 2019. It is expected to expand in that much rate. Nutraceuticals and also functional food, that means the society, the global society community is requesting, demanding these nutraceuticals and functional foods. That means, so we are having very big role of producing more nutraceuticals, more functional foods, because in this era, because that is the we need to combat this disease, right? So I mentioned, because we are working with these nutraceuticals and functional foods, and we are in preparing, we have prepared and we are in preparation of many functional foods with many plants, especially now these days we are working with guava, calcinia, this lawn coriander and cinnamon. So so we have already prepared some functional foods like soup mixtures with many, because it's a combined mixture with many plants, and also like a herbal tea blend. It's a combined, and we are working for functional water. There are many work we are doing, and also we have prepared functional beverage, like ready to serve beverage using like cashew apple. So those are cashew apple, as you know that cashew apple is discarded without using all over the, because cashew apple is available only some period of the year, and those are not used very much. Then it's better, because cashew apple is having a lot of nutritional value, medicinal value. So we are preparing it as a ready to serve beverage, like this work we are doing. Okay, then I think I talk a lot, and so it's better to close my session. And I just want to show you, this is my university of Ruhuna. This is located at south end of the country. So this is a nice place, the seaside. Yeah. So this is from sky view, and this is our main library. So I invite even your college, we can have a collaborative research in this natural product, and you also come, and after this endemic is finished over, we can do this active research as a collaboration. I welcome you all to here. And this is one of donation from India. You may know that, because we have got to our university. It's a very nice auditorium from you. It's a Rabindranath Tagore auditorium. This and your because sometimes your people visit to this place. This is one of a photo of that. And so I would like to thank for my funding agencies and also my students, because they are working hard to do this work. And thank you for all for your patience. Thank you.
Thank you, ma'am. First of all, thank you for showing your university. It's beautiful and wonderful. Thank you. Usually we don't get that opportunity to see such universities. And thank you for sharing your knowledge on emerging trends in natural product research, functional foods and nutraceuticals as a measure of reduction of the risk of non-communicable diseases. Thank you, ma'am.
Thank you.
So now, with the long list of his achievements and glory, I would like to invite Professor Dr. Charles S. Vairappan, Professor of Natural Products Chemistry, Institute for Tropical Biology and Conservation, University Malaysia, Sabah, Malaysia. And I request our Assistant Professor of Chemistry, Y. Mahesh, to say some interesting facts about the resource person. Welcome, sir.
Thank you. Good afternoon, respected faculty members and research scholars, my dear students. Thank you for being here this afternoon. It gives me an immense pleasure to introduce and welcome today's resource person, Honorable Professor Dr. Charles Shantanraju Vairappan. Professor Dr. Charles Shantanraju Vairappan is a professor of natural product chemistry at the Institute of Tropical Biology and Conservation, University Malaysia, Sabah. His career as a university professor began in 2001 Upon graduation with a PhD degree in chemical ecology from Hokkaido University, Japan, he then pursued his postdoctoral attachment from 2006 to 7 at the University of Tokyo under the JSPS fellowship. He has been working in the University Malaysia Sabah for the last 20 years. He is working with marines and terrestrial material from Borneo and have isolated more than 1,000 pure bioactive compounds with 5 patents, 15 innovative awards. He has also authored more than 150 scientific articles and produced more than 10 PhDs. Professor Charles is also very active in international student exchange between Malaysia and Japan. He is visiting professor of the University of Tokyo and international network ambassador for Hokkaido University and Kagoshima University in Japan. He is also board member of the Asian Federation of Biotechnology. His research passion in the discovery of lead pharmaceuticals from marine flora and fauna. So, and today he will be sharing with us his expert opinion on the emerging trends in natural product research, functional foods, and nutraceuticals as a measure of reduction of the risk of non-communicable disease. Thank you so much, sir, for accepting our invitation.
Thank you very much.
Accepting our invitation.
Can you hear me? Thank you. Yes.
Yes, sir. Carry on, sir.
All right.
Today,
thank you.
Yes, sir. Yes.
Can you hear me?
Okay.
Yes, sir. Please carry on.
All right. Wonderful. Okay. First of all, I would like to thank Ramesh and also Suresh Babu from IICT for the invitation. I think the title of my talk has been switched with the earlier second speaker. So mine is the title that was mentioned for the second speaker. So let me share the screen. Okay, the title of my talk is actually Structural Diversity and Biological Activities of Halogenated Secondary Metabolites in Red Algae, genus Laurencia in Borneo, Malaysia. So I belong to the Institute for Tropical Biology and Conservation, University Malaysia, Sabah. And it's a pleasure to be here to share the knowledge with students and colleagues. My talk will be slightly different as compared to the two earlier speakers. I will be talking about the actual data that we got from our laboratory, something on marine and particularly on red algae. As you can see, I come from the Institute for Tropical Biology and Conservation. So what I'm going to share with you will be from ecology, looking at ecological chemicals, and how the plants, marine plants in this case, produce this chemical, for what reason, and what is the diversity of the structure, and how we could use it for pharmaceutical, until I touch on the microarray expression of the drugs on cancer cell lines. So it'll be a diversity from ecology till delivery of a drug. So bear with me. So to start off with, Borneo biodiversity hotspot. I am somewhere here. This is the island of Borneo. This is the island of Borneo. This is the peninsula of Malaysia, Sumatra. And if you look at this island, one of the bigger islands in the world, and we have two states of Malaysia in this island of Borneo. Malaysia consists of peninsula, and we call it East Malaysia. There are in total 13 states, and 2 states are located in the island of Borneo. So I am from here, and particularly from a place called Kota Kinabalu. And as you can see, the island of Borneo is very rich with biodiversity. Species diversity is very high, and not to mention about the plants. There are several beautiful ecological niches. Ecosystem is fantastic. You have lowland rainforest, tropical rainforest. We can also find montane rainforests, peat swamp forests, montane alpine meadows, freshwater swamps, mangrove, heath forests, and not to mention the coral reefs that are around here. And particularly the island of Borneo and particularly of Sabah, this state, it's called Sabah. And we have a beautiful array of coral reefs that we call the coral triangle, which is huge, that it encompasses from here until almost near Australia. So that's where I get my resources from. So the island of the state of Sabah, the coral reefs are all around here, the coastal waters, and we have about 1 million hectare of totally protected marine park all around the state of Sabah. And as for its terrestrial ecosystem, we have about 27% of the forest or the landscape of this particular state totally protected land area. And if we can look at this slide, these pictures here, from 1990 till 2015, you can see the increment in the dark shaded landscapes. This shows that the state government and the government of Malaysia know the importance of natural resources, terrestrial natural resources, and we have taken steps to enhance the protectedness of this area, where we can see the increment in dark green shows more areas are being protected due to the concern of conversion of primary rainforest to agriculture, particularly oil palm. So as the oil palm increases, we have also made efforts to protect the land area so that the primary forest will not be converted to agricultural land, or the secondary forest will not be converted to a logged forest. So that is the conservation aspect of marine environment and the terrestrial ecosystem in the island of Borneo, particularly Sabah. Now, if we look at the coral reefs around the island of Borneo, if you were to go for snorkeling, you will find out that this is a typical, this photograph was taken a few years ago when I went snorkeling. This is a typical picture underwater. The water is pristine clear, and just by snorkeling, you can see there'll be coral reefs, there are sponges, soft corals, tunicates, marine fishes, and algae. And as you know, as even Suresh has mentioned in his first talk, that marine invertebrates, particularly sponges, tunicates, soft corals, they are known to produce lots of secondary metabolites. And this table shows the types of trademarks name of chemicals that have been developed by various companies, and then their therapeutics and how they are in different stages of manufacturing. And this particular one, carrageenanose, is from Eukema, is an algae, and is a iota carrageenan, an antiviral drug. So seaweeds are also important sources for secondary metabolites and lead pharmaceutical. So today we'll look at how in my laboratory, over the few years, we have been working on it. We were able to isolate a wide diversity of secondary metabolites from this particular genus of red algae. We have worked on a wide diversity of algae, but today I'll only talk about red algae. So the scope of my talk today will be basically, first will be the structural diversity of secondary metabolites, particularly the halogenated metabolites in red algae, genus Laurencia. Second, the importance of secondary metabolites or in this genus as important chemotaxonomical systematics with the interest of conservation at heart. Third, how we investigated the secondary metabolites for their pharmaceutical potential. And finally, the human gene microarray expression of some of these compounds in cancer cell lines. To introduce the subject matter, these are the seaweeds that I call Laurencia. They belong to the division Rhodophyta. They are red algae, macroalgae, red macroalgae. They grow on degrading coral reefs or boulders in the marine environment. Some also grow on ropes and other structures. They're very small, probably about 5 cm to maybe about 30 cm. The species A can grow up to about 30 cm. Species B can grow to about 30 cm too. C will only grow to about 15 to 20 cm. And this particular one grows maybe to about 15 cm. So they're all macro algae, they're all red algae, although this particular one looks a bit greenish, but still belongs to red algae. The A is called Laurencia snecki, B is Laurencia majuscula, C is called Laurencia nangi, and D is called Laurencia similis. Why I chose this particular group of seaweed? Because they are very unique. And you can see the slides here. This is the microscopic photograph of the surface layer of this algae. If you look carefully, you can see there are vesicles in their cells. Here there are about 2 vesicles, and here got 1 each, some 2, A and B. These are the vesicles where this particular group of algae biosynthesize halogenated secondary metabolites. Yes, halogenated. So their sesquiterpene, their non-terpene compounds have got chlorine or bromine atoms attached to them. These are naturally being synthesized in this way. This is not a synthetic artificial synthesis. They're growing in the sea, and they produce this array of compounds. And these compounds are biosynthesized and stored in these vesicles. And these vesicles are on the top layer of the algae. You can see a cross section of the algae. You can see the cells and how the organelles are aligned here too. And the organelles, the corps centellis, we call them the vesicles, could even be found in young shoots of the seaweed. So as early as possible, these compounds are produced and stored in this vesicle so that they could be utilized as a defense compound for this particular group of seaweed. Now, we isolated the compounds using the normal conventional natural product technique that Shure spoke about, and also the second speaker spoke about. I will not go too much in detail of that because the earlier speakers have spoken. But a couple of things that I would like to mention. We've got the 600 megahertz NMR. Most of our measurements were done using 600 megahertz. And we also use recycling HPLC. I'm not sure whether you are aware of it or not. We have modified our HPLC so that we can recycle the same peak over and over, so that a very close peak or an overlapping peak like this could eventually be separated to give very pure compounds. This is called a recycling HPLC. Uh, we have modified some features of HPLC to give us that semi-prep HPLC. With that, we isolated most of our compound, and we use NMR 600 megahertz for proton NMR, carbon NMR, 2D NMR, and I've got a LCMS IT TOF mask in my lab to do high resolution MS. So to talk about the results that we got, so the 4 main species of Laurencia, Laurencia snecki, Laurencia majuscula, Laurencia nangi, and Laurencia similis. These are their scientific names. And a simple TLC will show you that these are the spots, and you can see there's a lot of chemicals in them. And we have extracted this particular seaweeds using normal methanol, ethanol solvent. And then we do solvent partition using diethyl ether and water, and then conventional column chromatography, normal phase column chromatography with gradient elution, where we can get a beautiful chemical profile. And then by using either preparative thick layer chromatography or HPLC, uh, we have isolated the compounds. Now, for Laurencia snecki, as you can see, most of the compounds that we have isolated were sesquiterpene in nature. This skeleton is called a syndrine skeleton. And as you can see, there's bromine, there's functionality of OH, and these structures predominate in this particular group of seaweed. Laurencia snacki is known to have lots of sesquiterpene, halogenated, and also with oxygenated sesquiterpenes, where the total to about 20 compounds were isolated belonging to this group with various levels of unsaturation, various levels of bromination, and also the presence of hydroxyl group. So this was a very good source for us to get lots of secondary metabolites. And we also found some cuparan skeletons. This is a this is chamigrane skeleton. So you have a syndrine skeleton, you have a chamigrane, and you also have cuparan. Second species is called Laurencia majuscula, and this particular seaweed is widely distributed. You can find them in Caribbean, you can find them in temperate waters like in Japan, Korea, China, and the one that we found in Borneo only produced chamigranes. They were very specific in their metabolites that we got, and their chamigranes, carbon-15 chamigranes, sesquiterpene, and then they had halogenation, bromine, as well as chlorine. And we were fortunate, we isolated quite a number of these compounds, and there were about 30% novel compounds in them. So this was a very interesting seaweed to work with. And then this is the other group of compounds that we got, just to show you that some of these chamigranes were rearranged. Yeah, with side arms here, with the vinyl bromide moiety, and some even had linked chain links like this, bridging like this. And these are the variations that we got from chamigrane. And when we looked at the metabolic pathway, and this could be explained to be originated from chamigrane skeletons. So Laurencia majuscula gave predominantly chamigrane skeleton with chlorine and bromine as the halogen, but they also gave some rearranged chamigranes with some novelty. The third group of the seaweed is called Laurencia nangi. And this particular species has got very limited distribution. And to date, there are only about probably less than 5 publications, definitely less than 5 publications on the chemistry of Laurencia nangi, because it's only found from Vietnam to Malaysia. It's not found in Korea or China or Japan, not even in the European waters. So it's very limited distribution. So the compounds are also very unique. And here from Laurencia nangi, we collected quite a bit of carbon-15 estogenin. This is estolinic group, carbon-15 estogenin, with bromine and chlorine as the halogens, and very interesting skeletons. Yeah. And then not only this skeleton, we were also fortunate to find this is called a bromo-RN group, also carbon-15 non-terpene. As you can see, it has a vinyl bromide moiety, and it's a double bond. So we call it bromo-RN group. So this is the second type of skeleton that we got. The first one is estolinic carbon-15 functionality. This is bromo-RN functionality in the same seaweed, different populations. We also were fortunate to find some diterpenes from nangi, also halogenated, and also some chamigrane type skeletons, also from nangi, and triterpenes. This particular compound is of interest in today's talk, as this is a triterpene, and it had a lot of biological potential, and we have used this until microarray experiments. This is triterpenes. So in essence, Laurencia nangi showed structural diversity that was quite astonishing. At least 4 to 5 different skeletons were produced in this particular species. Of course, it all depends from one population to another population, but they had the genomic material, the genomic information to biosynthesize compounds of different chemical pathways, meaning they had these bromo peroxide enzymes that facilitated the biogenesis of interesting skeletons in this particular seaweed. The final species is called Laurentia similis. And as you can see, this particular population only produce alkaloid called bromoindols. Only 3 bromoindols were discovered from this population, and there were no diversity of structures. So I've showed you 4 different Laurentias, and I've showed you a wide diversity of structures. Next, we plotted all these in a tabulated, and we looked at population. So we have got 4 algal type here, and then we have collected from 7 different locations around the state of Sabah, the coastal waters of Borneo. 7 location, 4 species. Each location, for each species, we had 5 replicates. So this is the data. These are the seaweeds, 1, 2, 3, and 4. These are the populations. Each has got 5 population. And this is the structure, number of compounds. Here, skeleton type. And this is also number of compounds. These are the locations 1 till 7. So we tabulated all the data, and we wanted to see whether there was a pattern in it. So we did a Shapiro-Wilks normality test, and we found that the data were not normally distributed as anyone could expect. The environmental data are totally random. You cannot expect data to be normally distributed. So we were fine with that. So what we did, we plotted these compounds based on their structural type. We grouped the skeletons to from 1 till 8 for sesquiterpenes with different diversity or different degree of functionalities. There were 8 groups of skeletons under sesquiterpene. We also prepared 2 skeleton, carbon-15 estogenin and bromo-RN. We also had 2 more skeleton, diterpene and triterpene, and finally bromoindol. So there we had a total of 13 distinct skeleton types in Laurentia, the 4 species of Laurentia in Borneo. So we assigned colors for them. And then this particular heat map shows at the x-axis from skeleton 1 to skeleton 13. These are the skeletons. Skeleton 1 to 8 are sesquiterpene, 9 and 10 estogenin and bromo-RN, 12 and 13 diterpene and triterpene, and 13 is bromoindol. So when we plotted the data, these are the species, seaweed species, you can see that majuscula was all in one area. It shows that there's not much of diversity in skeletons. Same thing with similis. Of course, similis was totally no diversity at all. Majuscula showed diversity, and there was a bit of majuscula here, and bulk of it were here. Snaky also showed diversity, and Nangi, of course, showed more diversity, and the intensity of compounds are all showed based on their skeleton type. So heat map gave us a profile of the degree of diversity in the skeletons in this particular 4 particular species. Then we went one step ahead. We wanted to see whether the diversity of compounds were affected by location or by species. So we did a generalized linear mixed effects model. We call it GLMMs. So these are all for conservation purpose. So we even tested number of compounds with the species times location for one population, and then we did some statistical analysis. These are the details of the analysis. But what's interesting is that we wanted to make sure that we were able to run ANOVA, and then we saw there was significant difference in the effect of location. So the effect of location was important. So for a particular species, depending where they were collected from, the population belonging from 1 till 7 location, depending on the location, it seems to have an effect on the number of compounds. And effect of species was also important, meaning number of compound changed with the species. Number of compound also changed with the location. So the diversity in number of compounds had a positive correlation with location and also with species. Then we went ahead and we wanted to test whether the number of the skeleton type, was associated or correlated with location and species. And we found that the skeleton type had no correlation with location, but it had correlation with species. So these information are very important because we want to use these chemicals that we found, the halogenated secondary metabolites, as a chemotaxonomical markers in the systematics of the seaweed. Laurencia is a group of seaweed that's found everywhere in the world, and they show morphological plasticity. So in order to facilitate proper identification, now we have morphological identification, then it's been facilitated with genomic fingerprinting, and we have added one more tool to facilitate biosystematics of Laurencia, that is this chemical taxonomy, because they produce halogenated secondary metabolites, and the diversity of the compounds, the skeleton type, and their location could be used to classify or to give value to the systematics of Laurencia. So this is the conventional, the conservation aspect of the research, and we were able to correlate all this using logistic regression model. And you can see number of compound in Majuscula and Nangi are different compared to Similis and Sneki. This we were able to show. And then we will also be able to show no structural type in Laurencia, Majuscula and Nangi are different. To number of structural type in Majuscula and Nangi is different compared to Similis and Sneki. So this information is something new, and this is for the population that's found in Southeast Asia. We can extrapolate this data to some of the Laurencia population that we were able to get hold of from Philippines, from Indonesia, and from Vietnam. And we saw that this particular concept could be applied for the populations found in Southeast Asia. Then we also plotted this on a cluster analysis spectrum, cluster dendrogram. And here you can see is very clearly, it shows that Laurencia sneki this is Laurencia similis. There's no diversity at all. And it shows which is closer relative to which in terms of location. Yeah, 1, 2, 3 till 7 are locations. You can see the proximity of the compound skeleton and how they correlate with the location. So we could use cluster dendrogram to show number of compound, how they're correlated with the location, and also number of skeleton structure type, how they're correlated with the location of the where the samples were collected. So we got a lot of information just by looking at the natural product and using some tools, statistical tools, to correlate their chemical structure and their identity to the location and the ability of the seaweed to produce diversity of structures. Okay, now that I've spoken about conservation and how the chemicals could be used for taxonomy, let's move along to more interesting things. So I had a wide diversity of halogenated metabolites in my laboratory sitting in the freezer. So we thought it's only right that we use some of this compound to test certain things. So we wanted to see if this compound has biological activity or whether we could use them for human purpose in one day. So the basic thing that we wanted to test was anti-inflammation. Of course, we did this antibacterial, antifungal, but today I would like to talk about anti-inflammation and anti-cancer. So anti-inflammation, as you know, what is inflammation? Yeah, this is a simple picture showing how when somebody's leg or skin is ruptured with a stick or a thorn, and how it gets inflamed, and what actually happens in inflame. Chronic inflammation and cancer. Cancer is led by chronic inflammation, and how the triggers work. Yeah, this is the concept behind inflammation. So what we did, we tested all our compounds. We tested all our compounds using RAW267.4 macrophage. ATCC collection. So we use this particular macrophage as a test organism, and then we used LPS, lipopolysaccharide, as the toxin. So some of these cells, we treated them with almost about 1,000, almost about 200 halogenated metabolites that we collected over the years from Laurencia. We treated the cell with the compounds, and then we tested them with LPS. We challenged them with LPS, which is the toxin, and then we studied the NO production. Of course, like any other bioassay, we also monitored the cell viability assay, and we made sure that the viability were optimum or high. Here you can see cell viability is almost 100%. In some cases, 98%, but very high. So the cells were not dying because of the compounds. The cells were not dying naturally. And we tested the compounds at various concentrations and various compounds, and we found this particular compound, which is found from Nangi. It's a triterpene, and it showed very good activity. As you can see, 1.56 microgram per mil to about 25. And we also tried concentration dependent testing, and we can see how the NO production has been reduced. Yeah, the more compound you use, the lower the NO production. And you can also see the other data, the death of the cell is all at 0, no cells were dying, and LDH release were also monitored. So this shows that this particular compound had very good activity, very good response towards the NO production. So it suppressed the NO production when the macrophage was challenged with LPS. So this is a very good anti-inflammatory lead pharmaceutical. Then, like any other anti-inflammation test, we also studied PGE release factor, tumor necrosis factor alpha release. We looked at different concentrations. As we increase the concentration, of course, the activity got better. Yeah, but for TNF alpha, you can see, regardless of the concentration, the activity was already very low. So even with as low as 6.25, the activity reached maximum, and increasing the concentration doesn't show any reduction in the suppression of NO. Suppression of the TNF alpha factor. So therefore, this is a very good candidate for drug development. So PGE release factor was concentration dependent. TNF alpha release factor was not concentration dependent. And then we also tested IL-6, interleukin protein 6 release, and interleukin protein 1 beta. And again, you can see for IL-6, it was not concentration dependent, but for IL-1 beta, it was concentration dependent. So what is interesting is we have tested about 200 odd halogenated metabolites, and only this particular triterpene showed such unique features, which are preferred when you want to carry it over to other tests. With a very small amount, you can induce the activity, the suppression of NO, and also the suppression of IL release factors. So this is a very good anti-inflammatory response. And then we went ahead further. We also tested ENOS, COX-2, and beta-actin, like any other cytokine experiments, and they all agreed and gave us very good positive results, and to show that this particular compound is the ideal candidate as a lead pharmaceutical for anti-inflammation. Next, we look at anti-inflammation. You would like to also study chronic inflammation that leads to anti-cancer therapy. So we had few cell lines that we played around with. Finally, MCF7, this breast cancer, gave us the best results. Again, this particular triterpene showed fantastic result with the breast cancer. These are some of the images, control and with different concentration. Apoptosis could be seen. It's not very clear here because of the images are small, but we also did flow cytometry, and you can see the M1 region and how some of these percentages from 6 to 20, 26, and the concentration, it was concentration dependent too, the sub G1 content, and the activity was very good for anti-cancer MCF7 cell lines. We also went ahead, we wanted to see the caspase 8 inhibition pathway, and we were able to monitor BAX, BCLX1, P53 proteins, which are the basic gold standards for this kind of study through Western blot protein expression. And then we were also able to find the flip mechanism that was responsible in on and off of the breast cancer cell lines when we utilize these compounds as anti-cancer therapeutic compounds. So we were quite happy with the study this far. So we know that the compound showed, the particular compound showed anti-inflammatory activity. Then it also showed very good anti-cancer activity for MCF7. And we were able to identify some of the flip mechanism, some of the mechanism where it seems to be active. So then we wanted to know how we can take this forward. And a collaborator of mine in another institute had this unique organism called zebrafish, and we wanted to use that as a model. So ideally what we wanted was, we wanted to administer the compound that we've got around a particular growth or tumor. So we wanted to, as you know, cancer cell lines migrate using lymphatic system, right? Lymphatic system is the channel where cancer cell lines are distributed to all over the body. So we wanted to use the compound that we got to arrest, we wanted to see whether it can arrest the migration of cancer cell lines. Yeah, not to use it for based on the traditional, the conventional way, but we wanted to do something different. So we wanted to see whether that particular triterpene could actually inhibit the migration of cancer cells. So what we did, we used these zebrafish. These are zebrafish, all right? So there, a colleague of mine in another university, research institute, has wild type and two different types of zebrafish. These are all bioengineered zebrafish. So he has got this zebrafish, so we could actually use our compound and see whether the paracordial lymphatic lymphoblast cells. We wanted to see whether the lymphatic system can be controlled or not. So you can see there's a under fluorescence condition, we can actually, this is actually a real image of what happened when you look under the microscope with this particular zebrafish. You can actually use fluorescence dye and monitor the flow of the lymphatic system. So we were able to check the lymphatic flow in the zebrafish. So we wanted to see whether administering the compound, whether it shows inhibition of intersegmental vessel or not, whether it inhibits the vessel or not. So here you can see DIMSO. When you use DIMSO, paracordial lymphoblast could be seen. Yeah, but if you use the drug that is available in the market, SM, yeah, you can't see this particular paracordial lymphoblast tissue here. It could not be seen. Yeah. So when we use our compound, we can see this tissue being present. So the compound that we had does not inhibit paracordial lymphoblast formation. It doesn't inhibit the formation, meaning it does not inhibit the formation of the lymphatic system. It does not destroy the system. Yeah. Then we wanted to see whether what actually happens to the fish if we were to, sorry. Okay. So here we tested, we wanted to see whether the compound does or does not inhibit lymphatic sprouting. Yeah. So we found when we tested it against the fish in different concentration, we can see for DIMSO, we can see redness here. And here you can see for the compound that we use, we can see blood as well as lymphatic system are not compromised. But when you use SM, the standard chemical that's available, you can see that the blood doesn't flow anymore. So there's death of the blood veins. Then, but the lymphatic systems could be seen. So when you use our compound, what we were able to do is to arrest, it does not inhibit lymphatic sprouting. Sprouting was there, but it inhibits migration. It inhibited migration of the cancer cell lines. At the same time, it did not arrest the red blood cells. cells, the blood was moving in and out without any problem. And then the migration of cancer cell line out of the lymphatics, through the lymphatic system, out of the tumor was arrested. So this particular compound is very selective. So we could actually inject the compound around the, so you can actually inject the compound around the tumor area. It knocks off all the lymphatic system. So the cancer cell lines could not spread to other parts of the body, but the blood is still supplied. The blood veins are still active. So the tissue does not die until you remove the tumor. Then you remove the drug. You don't use the administer the drug anymore. Then the lymphatic system will start to sprout again. And then there's no problem. The migration of lymphatic system will take place without the cancer cell there. So this is a novel discovery, and we have patented this particular discovery for possible development as a lead pharmaceutical, especially for the lymphatic system and where the cancer cell lines do migrate using lymphatic system. So finally, we were also very keen to look at how we could use this information that we have and see which part of the cancer, the mechanism, which gene is upregulated, which gene is downregulated. So in order to see that, we had to use the microarray gene expression. As I showed you earlier from the start, yeah, where we started off with anti-inflammation, yeah, because the chronic inflammation will lead to cancer. So we started off with this, and then we found a compound that is active. Fortunately, that compound also showed anti-cancer activity, and it was against MCF7, that is the breast cancer. And we wanted to look at the mechanism. We were able to identify the flip mechanism, the NF-kappa mechanism, and also the proteins that were generated, and the apoptosis mechanism, cascade pathway, how the cells do die. We're very happy with that. Then we wanted to see whether there's any novel mechanisms in this particular compound, the triterpene. And when we tested it against this zebrafish, and we found that it selectively blocks the migration of cancer cell line out of the tumor area, but it did not stop these blood veins going in and coming out. So the cells did not die. And if you remove the tumor, then it comes back to normal, where the lymphatic system will still function and the tissue will recover. So this is something new. So then we went back to the original question of the cancer, the MCF7. So we wanted to know which genes were upregulated, which genes were downregulated. So we use a microarray gene expression technique. So as you know, this is one of the latest tools that we can use to study this sort of gene level testing. We use the same compound, but here what we did not use the conventional ATCC cell lines. We used a human primary breast cancer cell lines. These are primary cancer cell lines, meaning to say the cancer cells were isolated or were extracted from a real patient, fresh cancer cell lines. And these cancer cell lines were extracted from the patient, and these were primary lobular carcinoma, yeah. And then we also checked is a PT1, and then cells were positive for estrogen receptors like EPCAP, CD24, CD66, and so on and so forth. We checked all these, and then we use a fluorescence urine assay, fluorescence assay, so that, because we want to do a lot of statistics analysis in it. And then we also checked prior to the experiment, we also made sure that the cells were glucose starved for 24 hours. And then during experiment, we stimulated them with the 10 nanomolar of insulin with EC50 compounds, and for 2 hours under these conditions. And then after 24 hours, cells harvested and RNA extracted. So we extracted the RNAs, and then we use a Q1 azole kit, purify the RNAs, and then we use the gene chip 3000 system to study the human array gene levels. So there were two conditions that we tested, two hybridization per condition. T-test was performed. Now the HO was no significant difference. The null hypothesis was no significant difference in means of expressed value between experiment. Threshold P value was about 0.05. Yeah, and what we found was we had about close to 300 hits, meaning about close to 300 genes were upregulated and downregulated. Some were upregulated, some were downregulated, and the fold change cutoff is an indicator that we use. If the upregulation is more than 1.2 times, then it's something positive, something the gene is been activated, upregulated, or depressed, or if it's suppressed, is downregulated. So the particular gene that the chemicals work on, or the particular gene that the compound that we tested acts upon, could be identified here using this technique. And this is for human primary breast cancer cell lines. So with the hybridization, we were able to use to show this. And when you use this for the MCF7 cancer cell lines, there were a lot of genes that showed upregulation and downregulation. So for each upregulation, when we did a cross section, and there were about 300 upregulated genes. And then also for downregulation, there were also about 300 downregulated genes. So we had to decide at what point we would like to look at them. So fold change here, this is positive fold change because for upregulation, and these are the negative fold change for downregulation. You can see the -2 point something, and these are -3, -3, -2, and all. This positive 3 and positive 2 because this is upregulation, and this is minus because it's downregulation. So the classical book or classical what do you call procedure to study this, the fold change should be at least 1.2. But what we did, we didn't want to go as close to this as possible because this is very borderline, and then we'll have a lot of genes to look at. So what we did, we just wanted to pick the most obvious genes that were compromised with this compound, the most obvious genes that got excited or got depressed when we introduced this compound. So we only went to about fold change of minimum of 2, because the down regulation is 2 point something. Here is about 3 and 2 point something. So we made a cutoff point at 2. So any genes that showed up regulation to double the amount, fold change 2. For us, we accepted it as some significant up regulation. Again, for down regulation 2, if the gene showed down regulation to up to about 2-fold, then we'll take it as a positive effect of the compound. So we were able to identify these particular genes. Then what we did, we put them on a heat map. The green and red shows the up regulation and down regulation, right? So these are some of the genes and other aspects that I'm not going to go into. It's a bit too complicated. And we made a volcanic plot with 95% confident p-value, 5% cutoff. As you can see, the most of the compounds here, and the way we cut it off, and this is the 0 point, this is the 5% left and right 5%. So most of the compounds, most of the hits, most of the genes were here because we took 2-fold change. So we were able to see the changing of hybridization, the red and green color. Red was more obvious, meaning the up regulations were very obvious, and condition had no change on. If we go even, we can even bring it down narrow a bit, and it'll be still within the area. So the up regulation and the down regulations were not by chance. They were confirmed with statistics that this is due to the compound. Next, what we did, we wanted to confirm this using principal component analysis. We put the data on a PC1 and PC2, as you can see, and this is about 36%, this is about 35%, which is quite high for principal component analysis. And these particular two were standards that we used, and these two were the compounds that we tested. So the differences, up regulation and down regulation differences, were very, very obvious. They are not anywhere close to the zero line, meaning to say the genes that were upregulated were definitely upregulated, and the ones downregulated were definitely downregulated because of the introduction of the compound. Because these are the standards. Standards are very close to zero, and this is very obvious upregulation and downregulation, this compound. Again, this is also showed in cluster dendrogram. As you can see, the blue colors represent here, these two, and the red colors represent the up and down regulated genes that we have shown. So in essence, what we have done, we have used extensive statistics using principal component analysis, using dendrograms, cluster analysis to show when we administer this particular triterpene from Lawrencia nangi, and it was able to specifically target some genes in MCF7 cell lines. And these are not ATCC cell lines, these are primary cancer cell lines. And at the end of the day, we were able to identify highly expressed genes. And these are the AKR1C1-2. This is an upregulated gene. TPD52 is also upregulated gene. And this particular gene, steroid hormone metabolism enzyme, the gene that controls this, related to various cancer. So this particular gene is found in most cancer cell lines, and then they've got a functionality of steroid hormone metabolism enzyme, and have independent regulatory function in progesterone metabolism. As you can see, when we did the anti-inflammation, PGE2 was very compromised when we introduced this LPS. So this shows that the compound that we have used has direct effect on progesterone metabolism, and it also affects steroid enzyme metabolism. So we found out that this particular gene was highly upregulated. Again here, cancer vaccine target and its role as an inhibitor of DNA repair, this particular gene. This was also upregulated when we use our triterpene compound. Downregulated genes are these SPRY2 modulator of MAP and ERK pathways, and these showed fantastic downregulation. Also PLK1, target for P53 mutated triple negative breast cancer, and also KIF11, kinesin family members of 11 that contributes to progression and prognosis of human breast cancer. So very obvious that the three genes were the top three genes that were downregulated, and these were the two important genes that were upregulated. So as you can see in this particular study that I've shown, we started off from ecological study. We studied how the seaweed survives in nature, and how we can use the secondary metabolites that are produced by the seaweed to assist in the systematics of the seaweed itself. Then we utilized these compounds, we tested them on a very wide scope. We tried lots of assays, the antibacterial, clinical bacteria, activity against cancer, what do you call this, antibiotic resistant bacteria and fungus has already been done, and these are published. You can Google, you can find. And what I presented here is specifically to show that algae, particularly Lawrencia, derived secondary metabolites, particularly the halogenated metabolites, do have strong anti-inflammation activity, and we were able to trace that anti-inflammation potential to cancer cell lines, particularly breast cancer. We also tested other cancer cell lines, but the activity was not as good as breast cancer cell lines. And then we took that one step further to look at how the compound, whether it can show the same activity or certain different activity in zebrafish model. We did not use mouse because the conventional technique is to induce tumor in mouse and test them. Using mouse, as you know, it requires ethical clearance and it's a bit complicated. Zebrafish is much easier. It's simpler to get ethical clearance and to do this because the fish don't die because of this particular test. So we did that and we found that this particular triterpene compound could arrest could stop the migration of a cancer cell line through lymphatic system. It stops that migration, but it did not suppress the blood veins. The tissues did not die. The blood veins were as normal. And then when we remove the compound, the migration through the lymphatic system continued without any problem to the tissue and or the tissue around that area. So it was very good model, zebrafish, and we were able to do that. Then we got a bit more carried away with research. That's why we went into gene expression. And here we made sure that we used a human primary breast cancer cell line. And this technique that we use, we made sure that they are estrogen receptors, and then we made sure they are staffed by for glucose and all the other things. And then the upregulated, downregulated data also. We didn't take more than, as I told you about the fold factor. We wanted to get only the most obvious genes that were upregulated, downregulated, and this is shown in the principal component analysis. Because very often when you do a gene microarray, the data is always very close to the 0 point here. They were very close to the control cells. But in this case, they were very obvious because we insisted on taking a fold change cutoff point of at least 2, not 1.2. That's why we had such a huge difference. So these are the 2 genes that are upregulated. These are the 3 genes that were downregulated. So with that, in this talk, I was able to show you that the information that we got, we started off from ecology. Then our primary interest was for conservation, taxonomy, chemotaxonomy. Then from then on, because we had the compounds, we tested them, and we were able to trace it step by step from inflammation to cancer to animal model, and then to see how the compound is expressed in genes. With that, I hope students who have been following the talk will be able to benefit. And this work was only made possible with the financial backing for the Ministry of Higher Education of Malaysia. We also got some funding from Hokkaido University, from JICA, Japan, from Organization for the Prohibition of Chemical Weapons. These are some of the agencies that give us funding. Some of the essays, the zebrafish essay was done in Korea, Jeju National University with some collaborators. And then most all of my research done in Sabah, we receive clearance for sampling and for any test that we do. It has to go through the Sabah Biodiversity Center for conservation purpose as we follow the Nagoya Protocol very closely. With that, I thank you very much. I hope the talk would have benefited the younger minds, and you'll be able to take back some important things that we do at my lab. Thank you very much. That's all.
Thank you, sir. Thank you for illuminating the topic diversity and biological activities of halogenated secondary metabolites in populations of Redalge genus Lawrencea in Borneo.
Yes.
And thank you for such an informative session, sir.
My pleasure.
And if you have participants, if you have any doubts, you can ask, sir.
Yeah, sure. No problem.
And you can post your queries in the chat box.
Yes, thank you.
Follow it. Learning so many things nowadays because of these webinars. So please post your queries in the chat box. We'll move on to the next round. Means I request our assistant professor of chemistry, Mr. Vishanti Kumar, to propose vote of thanks.
Thank you, madam. Honorable Sri Naveen Mittal, IAS Commissioner,
Collegiate and Technical Education of Telangana, and Chief Patron of today's webinar. Respected dignitaries, our most valued speakers, participating guests, it's my privilege to propose a vote of thanks on this occasion. I am Vadiga Shantikumar, lecturer in chemistry of this college. We would like to extend our vote of thanks on behalf of the college and the entire team of organizers to all the speakers for sharing their expertise and knowledge on the topic recent trends in phytochemical research and drug discovery. It is a great honor that all the three renowned speakers have very charitably agreed to render their talks in the webinar. Before we go any further, we must make a special mention of Sri Naveen Mittal, IAS, Commissioner, Collegiate and Technical Education of Telangana. We from SR and BGNR Government Arts and Science College, Autonomous Kannam, are greatly indebted to our Commissioner, Sir, for encouraging us to organize this event. Thank you, sir. We also extend our sincere thanks to Dr. Balabhaskar, Academic Guidance Officer, for extending his support in all the academic activities and for his kind words. We would also express our gratitude to Dr. DSR Rajendra Singh, Regional Joint Director, FSC, Commissionerate of Collegiate Education, Hyderabad. Sir, we are grateful to you for your encouragement and gracious presence. Taking the opportunity to express our gratitude to Dr. G. Adagiri, Joint Director, FSC, Commissionerate of Collegiate Education, Hyderabad, for his valuable message. On this auspicious occasion, we first thank to Dr. K. Suresh Babu, Principal Scientist, Division of Natural Products, CSIR IICT, Hyderabad, for articulating his views on the intended topic for the webinar. Sir, we thank you from the bottom of our hearts for joining us today. We sincerely thank to Professor Wazira P. Bulugapitia, Department of Chemistry, University of Rufuna, Sri Lanka.
So you are not audible. We can't hear you. Thank you everyone for participating in this webinar. I thank you all. So a recorded version of this webinar will be available. Participants, please fill the feedback form. The link will be given in the chat box. It will be available for 5-6 days. The maximum limit of maximum limit is 100 participants per day. You'll all get your certificates within a week. So you need not to worry. It will be open for 5 or 6 days. Okay. With this, we conclude these remarkable sessions. Let's call it a day. Adios. Bye.